That song was probably a pretty good way to get copy strike, although you know, we're not technically broadcasting this. Okay, so let's see. I need to get the YouTube popped out so we can get that chat on screen. So YouTube, add bother. Yeah, wait, not toe. Oh, bother. There we go. I gotta get my stuff together today. All right, and let's pop out this chat. That's muted. Good. And then pop out the chat. Good. And then I need to refresh the page over here. This should probably work. Oh yeah, that one's still broken. Why is that broken? Oh, I gotta find that URL. Ninja Doc, I think that's the one. It is, but it's still stuck. How do I refresh the cache of a web page in Chrome? Reload is all I can do. Every time it reloads, it still has the same shit on it. Test. Yeah, nothing shows up. What the heck, man? I don't know how to do this. Oh God, it's so hot in here. What's going on? Oh, the fan is not turned towards me. I need the fan on me at all times or I die. Literally die. Okay, let's see here. This is a little too chill. I'm trying to get the social stream stuff working again. For some reason, every time I load it, it's the same exact web page, and so it doesn't catch up with chat. It's on last week's or the week before last's messages still. Like, I don't know what's going on here. What's up with this? That doesn't do anything. I have individual user things. User history of Nightbot should be interesting. Oh, it didn't do anything. Did Chrome break the plugin? That might have happened. Let's relaunch. Update Chrome, and maybe the plugin will be fixed again. The social stream plugin is, oh yeah, Chrome was running the music. Whoops. Oopsie doopsie. I made a poopsie. What's new in Chrome? I don't care. Ooh, it's all laggy. I'm back. Okay, there we go. Chrome is now eating all of my RAM. Track light, turn that on. There we go. Desk light. Wait for that to load. Oh boy. We are slow. Eventually we'll all come back. There's that page. We'll get this one open. Okay, there's that one. Minimize that for now. There's another. Start collaborating. Get out of here, Twitch stuff. All right, we're getting there. Wow, 6 viewers. How's it going? How do you bother chat? Just use the Twitch API to load up chat through IRC. That's not, we're not talking about Twitch. Oh, and this is working now. We're not talking about Twitch. I am talking about getting the YouTube chat, which is not an IRC page. YouTube chat is on a separate thing, and it's obnoxious. Okay, social stream blade over here. My desk lights did not turn on. Toggle. There it goes. These things lag. Stand light on. I really need to get that MQTT broker working. I guess I gotta wait like a month for Brink to figure it out. So I gotta just be patient. It's still stuck on the same. Look at this. It's stuck on last week. Oh wait, no. Look, it updated. There we go. I guess maybe the plugin updated with Chrome and everything. That one didn't update. The Sir Hiss and the, although it did get my titles one, so maybe that was, I don't know. How did this one get it and that one didn't? Do I need to refresh that one? Yeah, we're on YouTube as well. It's brought in a couple viewers, but I mean, I have 6 people watching right now, so a couple viewers is actually quite momentous. We need to open up the YouTube blade. I don't know if that opened up. It doesn't look like it did. So I'm going to go to Oh Bother VOD again. And then we will open this up. And then I'll pop out this chat. Yeah, I'm not popular enough to get tons of people from all over the place. Just gotta have that realization. Pop out chat and then close that and then go here and hit play on one of these. Let's go with let's go with this one. And now I have YouTube chat up, and that should all coordinate. Yeah, so I have on this computer, I have a lot of stuff going on, and I probably need a fourth monitor. But over here to the right, yeah, this is Deckard, my definition of chill. He does these chill mixes that are really good. So I have both of the chats popped out here in their own little blades, because if I put them into the tabs, I don't know if they work. I don't think they do. It's kind of loud. That's quiet for me. It's probably very quiet for you guys. I'll turn it up in just a minute. But yeah, so here's all my monitor stuff. So this is where I moderate my Twitch chat. My YouTube chat is over here, but I also monitor that in a different window. I have another window that actually has the ability to moderate YouTube chat. So if I need to do anything to YouTubers, or one of my viewers, I can do it here. And this shouldn't really be playing. That should just be paused. This is just where I control this from. And then, you know, these are the emails and stuff like that for YouTube. But then, yeah, Twitch and YouTube are here, but then they're combined all the way over here. So I've got this off to the side, which is hiding behind the other windows in my face cam. And then I have all of my monitoring stuff here so that I know what I'm broadcasting. So it's like, I have all this stuff. The master broadcasting window could probably go in a big, if I got like a big TV and put it up there, I could do that. So it's like when people have commentary about like what's going on stream, like, Bother, you left stream start soon on. I'm like, bitch, my head is right in it. Like, it is facing me right now. You're the one that doesn't know how much I know. Tell me how to run my ship. I start getting overwhelmed with 3. You know, I would love 300. 300 would be where I'd be like, I'm finally happy with life. But I don't get those kinds of numbers. I don't pull those kinds of numbers. Maybe not yet. A lot of people say not yet, but I don't know if I believe that. I don't know if I believe that. Spam. Man, the text messages ramped up. My glucose level too. I had kimchi ramen. Wait, so that message came in there, but it didn't come in here. So I need to refresh this one. So where's chat? Chat. Man, there's a lot of stuff. Chat back? Oh yeah, that gives you guys the little tint. And then refresh, go to properties, and then hit refresh, cache a current page. There we go. Now your messages should come up. What's going on, everybody? Sir Hiss and Trey Pop, how you guys doing? All right, so there's that. Let me put YouTube chat over there just in case. Just in case somebody happens to want to chat. I didn't work on a lot this weekend, and the subsequent nearly a week. It's Thursday. Jeez. Yeah, there's been a lot of stuff going on here, unfortunately, and I've been kind of embroiled in it. So yeah. Anyway, we're gonna work on. I got those products in, so we're gonna work a little bit on that power supply. What's up, Milk? We're gonna work on that power supply, which I haven't had a chance to work on. I should be much further along with this by now. But what I'd really like to do is get that screen running a little bit. And so we can look for and maybe use some of these tools that'll help me do the screen layout. Because that's going to be the hardest part, is giving it some kind of a design, like UI, that I'm actually not going to get mad with. I'll probably get mad with a lot of it. Fellow Tinker, and appreciate your channel. Bit of a nice respite from all the video games. Hey, you know, that's what I'm here for. You guys can follow along with these projects, and maybe some of y'all can help me out. But for the most part, I try to be entertaining about the things that I like to do, and I like to kind of get out there and show people what I'm working on. That's one of the main elements of when I started this stuff, is when I started writing for Hackaday. I was browsing Reddit at all hours of the night, and it was a terrible thing because I was just wasting my time. And then I see this post from Caleb Kraft, who is was the main editor of Hackaday at the time, and I just kind of showed him a couple little things that I wrote up about projects that I did, and he's like, all right, cool, you can do articles for Hackaday now. I was like, what? And so that kind of filled a creative element that I had been missing with all the government work that I had been doing, all the contracting work that I've been doing. So I was like, all right, cool, a creative outlet. Turns out I really need a creative outlet. So during a period of unemployment, I sort of ramped all this stuff up as cheaply as I could. And over time, it's been slowly improving. And here I am. I'm partnered with Twitch. I've made a sizable amount of money off of the previous version of this board because it had that little incentive to subscribe that people love. People love that. And I love it too. I love a little bit of incentive to subscribe to a channel. They also get to kind of try to pull the rug out from under me by subscribing absolutely filthy, heinous names to the board. And that's all good. That's part of the game that we play. But yeah, that's sort of my whole, like the whole raison d'art. I don't know how to say that properly. But anyway, it's sort of why I'm here, is to be entertaining for you guys. It's awesome. Remember the old BTS good times? Shut up. I'll get it running again. You shut up. Don't call it the old BTS. God damn it. I've been lax in my duties with BTS. I have. I deserve all the criticism I get, but for some reason I get a lot of criticism. So we are going to replace the dual op amp with our thing, and we'll get that up and running. And hopefully that'll definitively get these things running off of the high side, and then I can either work on the power supply on my own or do a little soldering session with you guys. But what I'd like to do really is hook up this screen to the breadboard. We need to get the level shifter. We need to get the power. Well, we have the power supply. We have our 12 volts here. Maybe we'll put the 5-volt power supply in this, and then we will hook up the screen and have a level shifter, and then I'll put the TNC4 against it, and we can see if we can get stuff kind of running. I don't know what the UI is going to be like. I don't know if I'll use these buttons as digital buttons, or if they should just be, well, they should be multifunction. If I've got like gate on a channel, I'll want to hit a button in order to do a gate. But I may also want these buttons to do other stuff, like menu navigation and stuff like that. Maybe I select the channel and then figure out what its personality is. That might be the end function of it. Or I just have a button that gets me into the menu, select the channel, press the channel, and then mess with it. And then once I'm done the selection, when I hit the button, it'll do an interactive thing with that channel. Maybe that's what it should be. Do these look like toggle switches? They're just buttons. They're not hooked up to anything. They're going to be hooked up to a port expander. And the port expander will go to the microcontroller. It's just I have to figure out what in a UI these are going to do. These LEDs I've taken out of the digital realm. They're not digital. What these LEDs will do is simply just display whatever is in or out on that channel. Like to pick your brain a bit, I've done a lot of breadboard projects that have migrated to soldered through hole. I've never done custom etched PCBs though. What would you recommend as far as software PCB company? I do things in kind of a weird way. And that's not to say that won't work for you, but it's not necessarily what I'd suggest, although it has worked wonders for me. I use Fusion 360, and Fusion 360 allows me to either pull in other people's models, make my own solids, 3D print stuff to my heart's content, but then it's also got a program in it called Eagle. And if you've got a good library in Eagle and you sort of curate your own good library of parts in Eagle, you can spin up circuit boards like 1, 2, 3, right? It's like super easy. That said, programs like KiCad are free and will remain free. So if you use KiCad and you use, what is the one that they love? There's another, what is the circuit design one? That is KiCad. There's a 3D design and a circuit board program that people love, and they're free. That said, you could also even use like Blender, or not Blender. I don't remember any program names anymore. I think Blender might be the one that I'm thinking of. Blender you could use for that kind of stuff. FreeCAD is one of them, or FeeCAD if you've missed the R key. Yeah, those are good too. And if you start with those and you learn how to use those, you're better off, because it seems like every other year, AutoCAD decides to change something about the agreement with their free software. They're tightening up the shackles on the free version, and the free version has some limitations. It's just I learned Eagle when I was young, and I learned AutoCAD in college, and it just that's just how I think about how to do this stuff. And if I need to, if they absolutely force me, if they squeeze hard enough that I plop out of the end of the program and I'm like, I'm not using this anymore, then I will go to those free options. I mean, my whole library of stuff is going to be invalidated at that point, but I still, you know, I know how to source the models and stuff like that between manufacturer and like FreeCAD or you know, all that stuff. Yeah, I'm altering the deal. Pray I don't alter it any further. They do that though. They keep changing the agreement, and it's like I probably need to like back up my whole library of stuff and put it like on GitHub. I do need to put a lot of my 3D designs on GitHub because I'm supposed to be giving those to you guys just for free, because it's just, you know, I'm teaching. I'm not making any money off of the program, I promise. Please don't kill my license. I'm not making any money. Just not even off the program. I'm just not making any money. I'm not doing it. I'm so sorry. Restart Fusion. This is probably it might kick me out. Oh yeah, we did a lot of CAD work. But yeah, this is it's nice to have everything in one program, but for the same reason it's also scary to have everything in the same program. Because if anything happens to the program, they have all your stuff on the cloud and you don't have anything on your desktop, because apparently we're not allowed to own anything anymore. The means of production have been fully taken away from us. It's obnoxious. I don't know if I caught what you said. Are you using a Teensy 4 or 4.1? Teensy 4. 4.1 is big and expensive, and I think a Teensy 4 is just fine for this. If I used a 4.1, this would balloon way out of control. I mean, I would love to package this in just this module, source a bunch of the screens, and then sell it, but I'm not going to do that. I'll put all the software online, and if anybody wants to go down the road of building something like this, it's a comprehensive piece of equipment that we are authoring here. And it's all just because I thought I could. It's such a big project. It sucks. Can you export your programs to a generic file type? Yes. And also the solid part and whatever files that you export to are, I think they can be converted. And you can also export to generic like STL files and stuff. Back in Eagle 7.5 era, KiCad 3 era, I jump shipped and never looked back. I should have, but through a consulting job that I had, I got a pro copy of Eagle 7, and so I used that through that interstitial time until Fusion 360 became much more usable. And once it did, I mean, it's amazing to be able to make these circuit boards and just, you know, put a 3D model out there and design solids around it. That's kind of what we've been doing here for a while. It's real neat. It's real neat stuff. Where's the module testing module? I don't really need to open this up, but I just happen to have it open. Boop, 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 boop. Where'd it go? Where'd the main thing go? There it is. Yeah, so like this. Eagles 4 to 6 a fair bit. I used 4 quite a bit, yeah. The old version. But I didn't have like a legit copy. But they also had, the pricing was like perfect for the hobbyist. But yeah, I was able to make this, right? Figure out where everything should be, make a little proto board, put that all together in CAD, and have that meet up through quite a few printing, actually. I printed quite a few of these to get all these spacings right. But now I've got a nice template, and I've been able to make it into a physical thing that actually resembles almost exactly the 3D model. I love that. I love that. I like that for me. I love that for me. But yeah, this will eventually become a tester. It just seems like I would be a little too restricted if I do standoff PCBs off the back of this thing. So I'm gonna do the bottom plate PCB and have a couple layers to that. And I'll have the power supplies plug in over here at the bottom, and then I'll have a stack of a couple PCBs with the different functions of this thing. I need to spread out. I mean, so far, AutoCAD has honored the agreement of the free version. They've kept it moderately useful for the hobbyist to use, and I think they really need, like, that has to be the model. Because otherwise, how do people use your CAD program, right? Like, we learn it in school, but like, if you learn it in school, you immediately go out to work and they have these huge programs. It's like, you know, learning the best of the best in terms of like PCB production CAD software. It's like, I didn't go to school for that. I went to school for being an engineer. And so now I'm expected to learn all the ins and outs of this program. And if you just give it to the hobbyists for free, hobbyists start to use it and they go, hey, here's a cool program. You should learn this one. Okay, cool. Well, yeah, let me check it out. And then you can go, oh, maybe I want to get a job in this. And then you can apply to industry and actually use that software. It's the best model. It's the Adobe Photoshop model. Everybody swears up and down by Photoshop, and you know, they cut their teeth with being pirated by everyone and their dog. Everyone and their dog pirated Photoshop, and everybody learned how to use it. Need to learn some CAD for 3D print stuff. The main foibles about 3D printing CAD things is just knowing your printer, knowing what your tolerances are for stuff. If you can get your printer to be pretty dimensionally accurate, even an FDM printer, you can get it to be very dimensionally accurate, and then you can know the foibles of how the screws you like fit into the holes you like to make. That sounds very dirty, and it is. But you know, knowing how to put two pieces together and what those tolerances are. And I've been doing this for a while now, so it seems like second nature to me, but it has taken quite a bit. Anyone that says GIMP is good is lying. It's what I use. That's what I say. Yeah. That's as far as I can. I don't compliment it. It's just what I use. But yeah, you eventually get to know your own prints, but it takes a lot of testing and iteration and sort of a bullheaded attitude towards it. You need to be a little bit bullheaded towards it. And eventually the chips fall in your favor. But it takes some effort. It's fun though. It's really fun to be able to go, I have this idea in my head. Let me put it together in CAD. Oh, all the parts fit together? Well, then I'm going to spin off a 3D print and then put that together in real life. And you're like, oh, there it is. There's the thing that I modeled in CAD. Pretty cool. Pretty cool. I just hope that we don't get totally sunk. I love doing the hardware. It's the software that really scares me. The software is scaring me right now for this project. You probably put this current sensor back together. This thing still works just fine. Took it apart to reverse engineer it, get to know it a little better. I know way more about low side current drivers than I ever wanted to know. Is that a shiny new breadboard? What's up, Flask? Yes, it is. I bought a couple new breadboards because, not just because I have, you know, project creep going on. That's that 303 filter right there, the diode ladder filter that I made Julian use. Not because of project creep, but because the breadboards go bad. These are so cheap nowadays that when you're sticking your noodles in them, it can ruin the clips. And so I got real frustrated with another breadboard that I put a whole circuit together. Nothing worked. That could have been my fault. But I am pretty good at putting together circuits. I'm pretty good at that. I've gotten good at that. You have to kind of learn all the details and stick in the details, and that's really tiring and boring. But here we are, of building the circuit. And then when you freewheel your circuit a little bit, there's mistakes, and you make a bunch of mistakes, and then something doesn't work and something explodes. I put together a circuit and I checked it over 3 times, and I went to power it up, and nothing was happening until I pushed on some of the resistors. I wiggled them a little bit. And the reason is these resistors have such thin leads that they don't really engage with the clips very well. And I got very frustrated and threw out the breadboard because I guess they just go bad. I'm getting there with tolerances when it comes to splitting large prints and giving them connection joints. I just want to be more confident in modifying models past that. Yeah, so with Fusion and AutoCAD in general, I mean, learning how a timeline works, you know, the algorithm that puts together your stuff, how to separate out different components and then get them dimensionally accurate and get them good and go back and edit that timeline is a lot to learn. Then on top of that, I'm not doing anything with like, you know, 3-dimensional like sweeping lines and stuff like that. Everything I do is squares that are extruded and then chamfered. That's it. So when you get into the more complicated stuff, it gets a little daunting. It does get a little daunting. But I don't know, I stick to my squares and chamfers and things generally go okay. I haven't branched out too much. I need to branch out a little bit more into the whole mechanical modeling aspect of Fusion, where I can set like joint motion and stuff like that. Because right now, if I just click on the screen, if I click on a component and drag, it'll just ruin the model. everything goes to shit if I do that. Whereas some people have models where you can click on the screen and like move a component through its motion. You're like, ooh, look at that. That works pretty well. I would love that. That would be really cool, especially for the RC car stuff. The RC car stuff broke me. I'm still working on it, sort of. I've put it aside for now. But that RC car stuff broke me. And the reason it broke me was because on that $200 super duper RC car kit that I bought, because I was like, screw it, I'm going to get an expensive one instead of dealing with all these cheap ones, and maybe that'll rekindle me a little bit on this project. And putting that thing together was a challenge in and of itself because everything's so small, but the components that were in that thing are insane. They have just like chamfers and fillets and chamfers on fillets and filleted chamfers and this and that and the other thing. Like I can't reverse engineer the mechanical part of it. I'm trying to, but there's like an order of operations that you have to do for things to make sense. And then once I get it physically modeled, I can then figure out how the body goes on top of that. But for now, it's been like totally daunting. I've been completely flabbergasted by the first part that I've tried to reverse engineer. There's just so much that goes into it. I don't know what those people are doing with their CAD software. It seems like they use Fusion, though. It feels a lot like they use Fusion. Because if you look at the models that they have, like the drawings of how to assemble the RC car, they look very much like the two-dimensional representation drawings in Fusion 360. Because this program will let you do all kinds of stuff like that. You can make like user manuals and stuff in this program. It'll let you put together and design all the pages of like a mechanical drawing that you'd send to a machinist and stuff like that. It does all that stuff. It's cool. I guess most CAD probably also does that at this point. But yeah, it's, you know, I learned through attrition, so I only know certain elements of the CAD software. It does a whole lot more than what I use it for, that's for sure. I've only branched out a little bit in some consulting jobs that I've done in the past. Always somebody who can't handle it, huh? Does it look like it's marked as a rerun? Why didn't your chat show up? Oh, there it is. Always someone who can't handle it. No, I'm live. I actually do still stream. It's been a little bit. I missed another Tuesday. I don't mean to miss all these Tuesdays. It's just I've been on demand in terms of moving boxes from one place to another. We've been going through some jewelry now, and it's like there's just a lot of stuff there, and it's hard to identify. One of our neighbors actually used Google Lens in order to identify pieces of jewelry, which is kind of insane. But it worked. It worked. So we've been kind of going through the pile of stuff left behind. Insanity. But yeah, I've been the only muscle available at times, so I've had to do a lot of moving things. It's just part of the process. Trust in the process. I'm gonna need some kind of a back panel on this thing, aren't I? Unless I do side panel. Side panel would be good because I've got all four sides right here, and then I can do power input, switch, and MIDI all from the side. I guess that may be the best way to do it. And I want to get back to the 303 because we've been in the middle of reverse engineering it, and I'm getting close to the end of the M303 in terms of reverse engineering, but I wanted to have a module testing module so I can make sure that this thing works. Because I keep passing it back to Dave, and Dave plugs it in and he goes, it doesn't work. Like, wait, why? Why doesn't it work, Dave? Why? So I need the capability. I need to be able to plug it in all into one place and you know, make it sparkle. What an immense pain in the ass it's been, but we're learning. Do you order PCBs just for the traces, or do you order PCBs with components attached? No, I give them, I mean, I'm good at soldering. It's one of my favorite things to do because I get to use my hands. So what I do is I use Seed Studio. It's actually baked into Fusion 360. You can just like tell it you're sending it to Seed Studio, and it will output a file that you then put in the Seed Studio stuff in order to order a board. And then you wait about a week and spend a lot in shipping because it's international shipping. And when your part comes in, your PCBs come in unpopulated. You solder all the stuff to it. But that's the most fun part of the whole process. And especially like making my own PCBs, man, it's so nice to be nice and organized and make something like compact. I could probably make this entire module, tester module, hardware on a custom PCB. I'm trying my best to not do that because I can build it, I guess, immediately instead of spending a lot of time sort of sweating all the details and figuring out what goes where. It would be pretty cool though. I would be able to make an entire PCB that would be the size of the back of this thing, and it would have everything on it. What's up, Shablam? How you doing? How you doing? We're just talking about doing projects and sort of the process behind it, and the stuff that I've learned and where I approach things from, how I approach these things. And it's my own process. It's been sort of many, many years. There's probably a different process if you follow a tutorial, but I mean, just this sort of iteration and printing is the way I do things. Planning with the 3D model, executing an idea, figuring out what the limitations are, printing the piece, fitting it, realizing everything's wrong, and figuring out where your corrections are. It's been a very frustrating thing because like I didn't know where these jacks end up when you just kind of insert them into perforated prototyping board. It turns out they're almost centered on the two middle pins. They're not centered on the middle pin. They're kind of right off centered here. God, that highlighting is annoying. Crazy times. So yeah, we're going to do a little bit about the power supply with the current shunt stuff that we've been looking at, but I want to get this thing, I want to get the screen up and at 'em. So we need to build this. I need to figure out what pins these are. LT1673. I think I have the data sheet open in another window. INA28X. People just come in and they like suggest different stuff for me to do when I'm like 4 hours into having researched and executed in one direction. They want to pull me in another direction, and it's like, stop. Stop doing that. I understand that you're smart. You don't need to prove it to anybody. I think this is the one that we have. They're going to have the same data sheet anyway. And then there's the data sheet. And everything else I should probably close. Oh, this is the one that I had open anyway. Yeah, I've got too many windows open. Let's cull the herd. Yeah, this is the, and there are alternatives, but we'll just use this over the top one. This is nice and simple. DC to DC, figure that one out. There's our inspiration. There's Octoprint. I don't need that open right now. Marbles is open just for one of the circuits. I already got that out of there. And the VFD displays I want to keep open because that's what we're going to work on next. I got to figure out how I'm going to basically design the look of the LCD, like what's going to go on the LCD and show us all the facets of the digital module testing module. So how do I display all 6 channels? How do I select one as an input? How do I display that input? That's all going to be stuff that I need to kind of start looking at. There are projects that help you design UIs, so I'm going to figure out if we can find a good one for monochrome, because our display's monochrome. That's another big limitation that we have. Got a monochrome display. Things can look pretty cool though. We can make things look pretty awesome if we do it right. Noritaki has also has tools that will help you do the display, but they're fairly rigid. They kind of section off areas of the LCD, and I don't think I like that too much. But if I display frames, then I need a frame buffer, and then if I have a frame buffer, what's the frame rate? What can the VFD actually support as a frame rate? How long do the pixels stay illuminated until they fizzle out? We were trying to look in the data sheet. We couldn't really find a good assessment of frame rates. There's probably some little footnote somewhere that would give us that information, but well, anyway, we'll figure it out. First, we need to do this. Yoink. There you go. That's what I need to hook up. Oh, aside from that, not a lot has been going on. It's just been day in, day out kind of stuff. I'm making an LCD sound system. That's because I have Daft Punk playing in my house. I do a good LCD sound system impression when I'm listening to it, but I'm not. He does a lot of this like screechy voice, and then he kind of lets it trail off. And so if you hand that up, you can do a good comedy impression of LCD sound system. Ah, there's so much. There's so much potential that I need to rein in and start doing some work on. I've looked a little bit into the LCD stuff, but not much. So maybe Chad will have some good suggestions. I don't know. We'll see. And then I need to get a haircut. It's getting a little unruly back there. I have to actually put shampoo in my hair and then wait a significant amount of time for the shampoo to do its job and then wash it out. I can't just spritz it all in and be done with it. Otherwise, my hair gets too heavy in the evenings. It gets greasy because I guess producing grease is like my job, my second calling in life. My hair gets very greasy at night, and then it starts to hurt from the weight. Isn't that ridiculous? It sucks. I've heavy volume hair. VFD sound system. Yeah, that's going to be my noise core version of LCD sound. I'm going to do noise core remixes of LCD sound system songs. And call myself VFD sound system. Sheep shears controlled with channel points. Look, that's something that like Uwo would do, and I'm not letting you guys anywhere near scissors. Anything resembling scissors, I'm not letting you guys anywhere near that. A chat controlled haircut, I think I may have heard of that tried to be done. I know people have tried to do robot arm haircuts, and they look absolutely fucking traumatizing. Geez, I mean, Uwo has the hair for it too. He's got long hair, so. But I'm sure as hell not doing. You guys cannot get anywhere near scissors. This is a first comment with a URL. Absolutely not. What is this? Are you trying? Is this your process? Give me a little text around this, a little context, because I'm this close to blowing away the comment, but it looks like it is relevant. What is this? Is this what you use? It looks like you're trying to advertise. Easier, cheaper ever to get your designs manufactured on a real chip. On a real chip? ASIC demonstration board. So it's just an ASIC board. You can buy an ASIC board. You can just go buy one. I have a couple. I don't use ASICs though. I don't know. I don't think a lot of people are sitting out here doing logic designs. Microcontrollers are kind of like where everybody's at right now. They don't exactly do what ASICs do. Actually, some of the microcontrollers have like FPGA elements in them now. They have some stuff where you can like insta-calculate things and put it through like a logic engine on some of these. I don't know if the TC4 has that or not, but I mean, this is what we're going to end up using today. TC4, eventually. First, we got to do just this little bit of over-the-top current stuff. If this works, I'm putting this circuit, not specifically this one, the one we're going to build, I'm putting the circuit on its own little PCB. Hold on, I'm going to cough. I had kimchi noodles for lunch, and they were very spicy. Yeah, that's a little weird, isn't it? I don't know. That seems a little weird to me. Why you would outsource designs like that. super fast ASIC design. I have, so there was either a group buy or it was, I forget what it was, that I did participate in. I didn't do anything with it, but oh, I see. So it's like submit your design, we're going to choose the best, and then everybody pitches in to make your ASIC. We dabbled a little bit in making an ASIC in one of my old jobs. They wanted to turn their proprietary solution for sending audio over Ethernet into its own ASIC that they would then sell. And it was a whole process. There's a lot of testing involved in it. You know, you start with a programmable chip, then they submit your design onto wafers. The wafer goes into what's called a glob top, which is they just deposit it into like a frame, like a pin package frame, and then do all the gold bonding wires themselves, and then put epoxy over it. So you get this globby kind of top chip, and then from the glob top you do all your testing and get all the kinks out, and then create from there an ASIC, just a chip that you buy. But it's this whole involved process, and it's any project that a DIYer is doing, somebody who's willing to perhaps submit a design to a manufacturer of ASICs. I don't really know if that's such a weird idea that you would group get that kind of thing, because like hobbyists don't get to that with their own designs. Like I don't understand where that's going to be relevant. I'm curious to know, but I just don't see how that's a good idea. I mean, especially with the stuff we're doing, it's having the versatility of reprogramming stuff is very important. I think it's at the bottom of this one. It is not. Where did it go? I have this thing that's called the Tiny FPGA, and it's a very, very small Arduino-shaped FPGA, which is like the ultimate ASIC, once you learn like Verilog or whatever. It's in here somewhere. Well, I can assure you that it's in here. I just don't know where. These are Teensy 3.6s, so these are already obsolete. It might be worth to try to use one in here, but the Teensy 4.0 that I have, this thing is like 600 megahertz out of the box. So I'm going with that for this design. Maybe we could use these. The problem is if I use these, then nobody else, like, restart to install the latest Windows update. Snooze. Yeah, it's just not useful to me. Strange. If you want to make an ASIC, it's an ASIC. It's an application-specific integrated circuit. So how do you outsource that? Why do you outsource that? Who has that kind of need? Who has that kind of like... And I guess they probably found a bunch of backers. I just don't understand how that all plays out. Where the hell did this thing go? I had the Tiny FPGA, I swear. It's in here somewhere. We never got around to using it. Is that it? No, it's an ultrasonic thing. I don't know. I got to get that MQTT broker working. Oh, here it is. I found it. As soon as I thought about it. No, that's not it. Never mind. Get people to learn the tooling. I see. How many of us use ESP32s as our daily driver? They're quite useful. I don't have them. Being able to program it over just like an IP address is kind of neat, though. That's kind of cool. Not having to plug in the stupid USB port. You could just program away and say, hey, send that over to my microcontroller. And it just works. Yeah, the onboard serial chips are good, too. You can actually physically program them if you need to. But, you know, being able to just throw your code over just over the air is pretty neat. And then if I did that with the module testing module, I would have the option of, you know, sending data to the computer. I don't really want to crack that egg yet, though. Let's put this thing back together while we're the current sensor back together while we're sitting here. While we're sitting and shitting. We just need to solder the screen back on. It'll probably be a little bit crooked. Let's get my big solder over here. We know fully how this thing works, aside from how it makes the screen work. We didn't really need to know that. But it's basically just a microcontroller with some analog inputs. The mix today is Deckard of the Space Cowboys doing one of his chill mixes, which I do quite enjoy. So if you want to listen to this music, you just go there. Only the Twitch people hear this, though. Everybody else thinks I'm insane. All 1 or 2 of my viewers on YouTube. Kind of sad that my VOD channel didn't take off very much. Maybe I should publish the VODs to the main channel. But if I do edited videos, I think they're gonna get way more traction. So I have to think about doing edited videos again. I still have about 100 VODs to upload too. I got to get back to that. I've been a little negligent in that one. I don't have the money to hire somebody to do it. Get somebody on Fiverr to upload all my shit. By Telegram over the air. Interesting. Is that what they call it? Is that what the kids are calling it nowadays? What direction does this go in? This way. Ah! Son of a bitch! Okay. So, which is the inside? Smooth part is the inside, right? These are rough on the outside? Yeah. Rough on the outside, just like me. It's like this. And then the opposite, the plugs are the opposite of V and A. OTA is a thing in and of itself. Yeah, I don't know how it does it. I don't know what the mechanism is behind that. This needs to, like, the plastic needs to bend a lot for this to go in. I don't want to break anything. Don't want to break anything. End up breaking everything. Just get something to bend that with. Tweezers usually help. All right, fully reverse engineered, now back together. I think this one still has the protective stuff on it, but these two don't. Doing it right now, you pervert. I need to get some of the scope shit out of the way, but we may need the scope, so I'm gonna turn that on. It's like sitting on top of a throne of trash. And then I made a little bit of progress on the CNC machine that I'm trying to build. Pseudomaze, you've been here forever. How can you not know what the project is that I'm working on? The CNC stuff I made a little bit of progress with. I ended up cutting a stainless steel tube in order to make the shaft adapters for inside of the gear reductions. The gear reductions are, I mean, I want to use them. I don't know if they're going to be fully necessary, but you know, I was thinking about, like, do I want to CNC I do want to CNC the milling machine eventually, but I think for now I'm just going to go ahead with building the desktop CNC with the router on it, and using those gear reductions and figuring out just what happens in the end. So if we get this module tester module hardware together, that'll open up the desk a little bit, and then I can bring this stuff in here and do like an assembly day or something like that. I did a lot of machining on Wednesday in order to get the 4 corners of the milling machine like together. And now that I've got that, I need to do the horizontal, like the x-axis. Got the Y kind of ready to go. I'll need to cut the big rails that I have that are potentially hardened. So I'll probably either be doing a lot of dremeling or get the angle grinder out, which scares me to death. That is a very dangerous tool. Synchronized clocks for the school I volunteer at. That's pretty cool. Yeah, that's a neat one. I could never read an analog clock. My parents were shocked to discover that my school never taught it to me. It just thought everybody knew how to read an analog clock just automatically. It was pretty bad. I'm just lazy. You know. I can read one now. I just couldn't in the past. There was a time when I was a kid. I never learned. What in the hell is that signal? It's just noise. Noise, noise, noise. The problem with making your ESP32 clocks all talk to each other is that they can be hacked. All right, what kind of security do you have on the signals? I'm gonna cough. You may need a little bit of security, like an encryption key or something. Also, an 8266 is probably enough for that. Oh, you have it doing the clock movement, the ticks. I've seen that before. I know a lot about that, actually. You can interpolate, actually. You can interpolate from what Bother knows, what Bother's already worked on, and what involves clocks and timers and ticks, and figure out what I'm talking about. Yeah. Zero detection is done with the CNY. What's that for? For the clocks? Zero detection? This is a song that just says music over and over again. Oh, the product that I got in. Let me get that stuff so we're all prepped. We're all raring to go. I am champing at the bit. Remember, it's not chomping. You don't chomp at the bit. Champ at it. Champ. Go get him, champ. At the bit. Wait, I can't tell. What is this? Is this music? It had better define itself, or else I'll be totally lost. I think it's done saying music at us. You can tell when the hands pass over the sensor, depending on how long the eclipse is. I can tell where the hand is on the face. Oh, weird. Oh, it's music. Okay, thank goodness. I was confused for a little while. We're definitely listening to music, chat. What am I going to do with this yo-yo thing? This yo-yo board that I never do anything with? Some of these things are genuinely useless in my hands. Oh my god, we get it. It's music. I understand fully. You said it about 1,000 times. Stop saying it. Stop it. I'm going to press charges. Oh my god. Do I not care? Make them stop saying it. I hate songs like this. I hate them. When they don't shut the hell up. Stop saying it. All right, this will be a good one for putting the board down. Make it stop. Make them stop saying music, please. It's something that house does a lot. House music does this a lot. I can't fast forward because it's SoundCloud. I would almost mute it, but I think this song is out of here. There's a battery on each clock on the 18650 the last couple days when I put the ESP32s in low power mode. The ESP32 only gets an NTP time a few times each day. Yeah, that's the way to do it. You got to have it go to sleep, go the F to sleep, and then wake up. I think something not 32-bit would be a little bit less power consuming as well. Like an ESP8266. Like, you don't need a heavy hitter on that kind of a job. This is where you design it on the big microcontroller, and then in order to get it to your specifications, you can then fit it onto a specific platform that is less powerful and less power consumpty. Power consumpty bumpty. That's a total use case for that sort of development pathway. These are like $5 each. I'm not happy about having to purchase a very specific chip, and if I'd followed the advice of chat, I probably could make some kind of a generic circuit in order to make it work. But I decided to go along with what I learned that day in chat. I didn't do anything with low power on ESPs, but I do remember somebody asking about that, and I don't know any of the sort of how to initiate all that stuff. I don't know how to do that. I've never had to do that. Always listen to chat. No, because chat is a bunch of people that have totally different ideas, and you've got to understand the psychology of chat. You come into the space where somebody is doing something that you know, and it's like, I know this. I know how to do this stuff. I've done this my specific way. I need to share my specific way, and I need to share it so that I can assert that I'm smart, so that they know that I know what I'm talking about and will respect me properly. I have to fight that because I have 30 people that want to do that, and they all try, and they all try to get me to do what they know. And it's like, why is he being so bullheaded about this? I've told him the answer. And it's like, there's a lot of other people here that would like to figure out and see the process of coming to that answer, of coming to some type of answer. So like, chat is always right. Yeah, but they don't know how to be right. They don't know how they don't know how to respectfully be correct about something and influence the streamer to go in a direction that they know what to do. It's one of those situations where I would rather people not say anything and just let me fail. There have been some times that I have not been able to fail because chat has been goading me on, and failing would show, first of all, that I'm human, second of all, that this stuff does not always work. This kind of stuff we're doing doesn't always work. Sometimes you fall flat on your face, and the risk of falling flat on your face is part of the execution of a project. You need to put yourself out there. You need to put yourself out of your comfort zone and fail. And that's growth, right? YouTube doesn't show that. YouTube, the person goes, and then I used my custom scanning electron microscope to view this. They don't go, and then I had to find this thing, and then I have a scanning electron microscope, but it doesn't really work. I need to make sure that works, and then once I vetted that out, I need to make sure that, like, they don't do that on some of these things. And sometimes you fail because it's funny, too. You know, sometimes I like to show the comedy. So there's a lot to it. There's a lot to what you know, how to present something like this. And Lord knows that I shouldn't be talking definitively about any of this because I have about 4 viewers, and I'm definitely not doing great in terms of being a professional streamer. I'm doing better than a lot, though. Failing working on a new project is part of the journey. It's part of why this is funny. It's part of the zany part of doing projects on camera, live. Because, you know, I've broken a couple milling bits on camera. I've gummed them up with aluminum before for you guys. It's good because all of my one friend is probably pretty mad at me because I'm supposed to have sold all of the milling bits that I use. I'm supposed to have sold them. They were from an estate sale, but I kept them. Your stream starting soon thing is still active. There's always fucking one, and this time there's 2. This one even has a badge. How does this one have a badge if he doesn't know this fucking shit? Fuck. It's not, no, the stream has started. Most streamers sit there, and they sit there, and they're like, while the stream starts, splash page is up. They're still streaming. I hit start streaming on my stuff. So did they. That's not a feature of Twitch. Chatters seem to think that Twitch, the stream start soon stuff is a feature of Twitch. No. Stream start soon is in effect my way of getting as many people as possible together so that I can explain what I'm doing once. It doesn't work, but I get to explain what I'm doing once. And it keeps people informed, and it allows people to be up to speed with me. I had 6 people in chat before. I'm not going to explain to those 6 what I'm doing and then have a bunch of people come in and go, what are we working on? How do you not know that, of all people? Or are you just trying to fucking trigger me? Because it worked. It worked! Or I'll just sit here not talking. What's up, esports? How you doing? Oh my god, why is it so hot down here? What is the temperature? 57. Oh no, that's the precipitation. 57%. 74 degrees. Inhospitable. I'm scared of this screen. I got to figure out what we're going to do with this screen, this VFD. We should be able to get pretty cool visuals coming out of it, but I need to learn how to program for screens, and I need to learn I guess a helper thing. There's a lot of helper projects that can help you design UIs, and I'll have to do a monochrome UI because it's a monochrome screen, and figure out what kind of like highlights and bubbles and interactions there are that will make this thing useful. I ate spicy kimchi noodles. I had a buldak kimchi, which previously I had kimchi ramen. It was, I forget whose ramen. It was one of the good ones. One of the really delicious ramens that was also kimchi flavor. So I've eaten a lot of kimchi ramen in my day, but this is the buldak one. So it's like extra super spicy. It was great. It was really, really good. But that means that it's in my stomach, which while talking to you guys in a theater voice, means that I'm going to be burping and suffering during this entire stream. I'll make it, though. We always make it somehow. Somehow we always survive. We're going to survive this one. We're going to make it, chat. I got an inquiry about fixing another M303 that had been, unfortunately, plugged in during a lapse of brain activity. In which case, I need to track down that PDF. I need to track down that PDF, and I don't know how I'm going to find it again. The one that had the specific fixes for the M303 when it was plugged in wrong. It happened so much that the creator of that module has made a PDF for replacing those specific parts, and I want to find that again, because if I get one in from somebody else, it's just a couple parts to replace. And so if I stick to those, replace them, don't plug it in like an idiot, don't blow it up, it'll probably work immediately, and then I can send it back out. And it'll be a wham, bam, thank you, ma'am, done. And I can wipe my hands of it and say, hey, if anybody else needs ones to be fixed, here's what I did. Because I fucked Dave so bad with this. I plugged this thing in upside down, and it blew up again. So I need to figure out what's still blown up with it. I won't have any way to test the 303 until I'm done this thing, too. That would be a little bit of a lapse. Built a watering controller with an ESP32. It programs the time into a battery-backed real-time clock, then gets the time from it and converts that time into binary-coded decimal to the format time.h likes. Damn, that's nice. Yeah, timing projects are pretty cool. I wanted to do a watering project with the like alleyway that's just over here because we have a huge garden in it and like all my hot peppers and stuff like that are all growing in there. And you can print, you can 3D print now, drip feed or whatever those are, the distribution systems. So all you have to buy is the tube. So you buy the tube and you really fit those things on there and you figure out what your design's gonna be. And that sounds like a lot of fun. It's figuring out how the tube is going to everything and then putting that on like an ESP timer that could be triggered from Node Red so that I'd know weather and time and stuff like that and have it interact properly. There are watering controllers that are smart that actually do, you know, look at weather and precipitation and moisture and soil from online sources for your local weather stuff and figure out when to turn on and off the faucets. But making one yourself sounds a lot cooler too. It sounds like a lot of fun stuff. The pre-recorded stream starting video is both gathering viewers and weeding viewers out. Why are we weeding viewers out? Well, okay, there's weeding viewers out, I guess. You almost automatically triggered that. That's funny. You like, as if just to prove your point, a bot shows up just as you say that. That's funny. I don't know about weeding viewers out, but like allowing people to gather here so that I'm not talking to 3 people about what I'm doing today. Yeah, so I can spin up all the viewer bots and get as many viewers as possible. I was wondering when we were going to pick up the project again. It's all I've been thinking about, aside from doing a little bit of machining. Sorry, I'm late. What? What the hell? I'm broadcasting to like 60 people, dude. All right, here's this. Here are these parts that I worked on over the weekend. Actually, yesterday, I was sitting here, day before yesterday, actually, I was sitting here manually machining these, and the unfortunate part about the manual machining is that I don't have a DRO. So my repeatable operations in terms of distances were not working out. But what these are bolt holes. So the bolts go in like this, and they're nice and flush with the maker beam. or sorry, the 8020 rail. These, unfortunately, were a lot of processes when I was machining. I made a little insert that has all the holes in it that I wanted to make, and then I have to take the milling machine and I line up the Y to be in the middle, and then that stays in the middle for the whole operation. But then to get those X distances, I have to line up the bit, take out the spindle, put in the drill bit, drill, take out the drill bit, put in the milling machine, flatten, move to the next spot, center it, take out the thing, put in the drill bit, center the drill bit, drill, take out the thing, put in the milling bit, mill. Then I had to do that for every single one of these 16 holes that I made. Every single one. So basically the operation of lifting and lowering the head of the milling machine, I am like, if I do this to somebody, I can kill them to death because I'm so strong with these muscles now. Sounds like fun. It was not, but it was motivated. It was nice, repetitious work for my ADHD brain. CNC would be your friend. What do you think I'm building? What do you think this is? A clown show? You think this is a clown show, don't you? It's not a clown show. It's a milling machine. It's going to be a little desktop milling machine. And I'm using three-phase motors, but I'm also using gear reductions on it. Why? Because it's a small desktop mill, and I want to see how accurate I can make it. So I am using, unfortunately, these are not ball screws. They should be ball screws if I really want to go for broke, but I don't want to spend millions of dollars on this thing, so I'm going to use a lot of the stuff that I have already. Build it so you don't ever have to do it again. I eventually want to modify my milling machine because it would be, all the stuff that I do with it, it would be better if I could just put it on a keypad and it would just move that distance that I want it to, even for the weird jobs that I do. I mean, I guess a power feed wouldn't be too bad, but I don't know. I don't know if I need all that. You really feel like you've built something when you have the manual milling machine because you turned all the knobs to make things happen. So I don't know. I'm on the fence about that. But yeah, that's what I was working on over the weekend. I thought this would be a much quicker job, and it's not. But all I need to do now is figure out what the cross beams are going to be, and then I will have the first axis, and I can start playing with the layout of this stuff a little bit and getting the motors mounted and spinning the shaft. And then I also need to get the rail cut out too. You have a garden of hot peppers. Some require watering every day, other every 2 days. So I took one of those blue barrels, filled it with water. Oh, that's cool. Got a 12-volt pump with 2 solenoids. That sounds like an awesome, that's a really cool project. Filled it with water, got a 12-volt pump, 2 solenoids. Turned out the solenoids needed to be driven with reverse polarity to close fully. Oh, weird. So I used a relay module to make an H-bridge. Very cool. Yeah, that's the kind of thing that you buy modules for. Really, that's a really cool project. That's a nice straightforward project too, and you get to play with water. Beautiful, beautiful project. All right, so that's true. Yeah, you're okay with not, you can just say you designed it and then, well, so the CNC, I'm hoping I'll be able to make some really, really small parts out of it because I can then make little tiny RC car parts, I guess, or just whatever comes our way out of metal instead of just plastic. I hope. I think it'll have some uses, but it's going to be a slow machine. It's not going to be a quick CNC, although I think it might be able to be. We'll just see what it's capable of when I'm done, and then I can, I guess, figure it out from there. I can scale it from there. But I have never built a CNC top to bottom, and I've got a Granite Devices motor controller, so I just need something attached to that that's going to do all the CNC stuff. Maybe a Linux CNC box. Maybe I can make that box Linux CNC, put a screen on it. With that, I mean, there are also solenoids. Sorry, not solenoids. There are relays that you would click in either direction. But I guess you're saying you need to drive the solenoid backwards. Wouldn't you want just like a membrane solenoid on the whole thing? There's all kinds of ways to do that. Yeah, it's a pretty cool project. I like that a lot. Especially given the variations in watering that all the different plants have. I was just going to stick a bunch of that drip tube behind everything, and just everything would remain moist at all times. Yeah, cheapo solenoids, you run into all kinds of weird stuff, but you know, you can get anything from cheapo to super expensive. Some solenoids have like a trigger over mechanism where you trigger it over to open and you trigger it over to close, and it'll withstand the pressure of your water lines, which is like, what, 20 PSI, I think is standard? Or is it 12? I forget what pressure hoses use. The problem is, a couple years ago, I left the hose on, and it's one of those expanding stretch hoses. And so it was sitting in the sun, and all of a sudden one day I hear, wait, is that water running? And it had been in the sun, and it exploded. The hose was just, you know, leaching water out. It was spraying water out, actually. So with the hoses that we have in the garden, the ones that collapse, you got to be careful with those. They're very fragile hoses. They work great because you can have it shrink and just stick it in a basket, and there you go. You're done cleanup. But still. Boom. Boom, boom. All right, let's get started. I'm going to get started. Let's get started. Let's do this. We don't have timers here. I just start whenever I want. And this is not an uncommon thing. I don't know why I'm the one who always gets shamed for this shit on this platform. I'm the one who always takes shit for having a start soon logo up while I'm just talking to you guys. And yet I can go into any given stream and they already do that. House's water pressure regulator should be set to 60 to 80 pounds of water pressure for the house. I see. I did not know that. That's a lot more pressure than I thought there was. I thought it was like 20 to 30. A lot higher than 80 pounds. Is that real? Hold on. Home water pressure PSI. Don't you answer this AI. 45 to 80 PSI. From Chas Roberts. How to know if your home has a normal water pressure. That seems like a lot of pressure to me. That's crazy. Oh, that's what I just did. Yeah, I just did. You're correct. That's crazy. That seems like a lot to me. Okay, anyway, well, you know what? You know why that? You know it seems like a lot? It's a lot for a camper. I remember looking up pumps and finding specifications as per camper water pressure on these pumps. Back when I was water cooling PCs, before that was a cool thing to do, when the only water blocks you could get were like Australian swirly blocks, I was looking up pumps and I wanted to get like an industrial pump that would water cool my PC, and a lot of the specifications were for 12 volts from a car battery into the pump, and then what kind of like head, like how high it could pump the water. And I think pressures were then 20 to 30 instead of 45. Okay, so was it about 1 hour? Yeah, an hour and 12 minutes until I ran out of stuff to talk about. And we got a good crowd going. We have a much larger number of viewers here. So what do I want to work on today? Yeah, so things have been progressing along with the module testing module. I've been kind of working on a couple other things or just sitting here with my mind a complete blank. On Tuesday, I had to move boxes. It's just something that's going on in real life, but what that did is allow us to get some of these parts that I ordered from DigiKey. DigiKey kind of drags their feet unless you pay them money. You can pay them a lot of money for super quick shipping, or you can just wait a couple days. And unfortunately, I don't have the budget to do super fast shipping, so we have to wait a couple days. So we were waiting for these over-the-top current drivers. Now, there were other things I could work on, but I had to help people. But these over-the-top current drivers, over-the-top op amps, they're called as such because their source voltage can be much lower than the voltages that are going into the differential. And I don't know, they do weird stuff in order to achieve that, but they were the ones that were recommended to us in the white paper of the solution that I found for turning a low side current sensor into a high side current sensor. You make what's called a current mirror, and because these things can be powered off much lower voltages than they're fed, they allow you to have something like a 3-volt op amp get a 12-volt supply current reading, right? Otherwise, you can blow up your op amps, and that's sort of what happened. What we tested, and nothing happened because we weren't using the right product. Unfortunately, it's fairly product specific. Now, there are ways to do it without buying a $5 op amp. I just wanted to continue on with what we were testing and actually get some closure on it instead of trying some random person. And I know the people who are making suggestions weren't random. I know who they are, and they make good suggestions. It's just I don't want to do what you want me to do. I have to drive. I'm driving. It's my stream. I get to do what I want. It's my stream. Anyway, so yeah. Well, so yeah. Anyway, what we're working on is finishing that, and having finished that, once we get a good test going, I can then, on my own, build a little tiny circuit board that has that circuit layout on it. I don't want to subject you guys necessarily to that because this is, again, we're branching out and things are getting very boring. I want to continue with sort of punchy project stuff and getting stuff done. So what I'd like to do is if we can finish this, if we can kind of close the door on this very quickly, then I can go and try to get the LCD screen working. We can try to get the LCD screen working. All right, so let's try to get this circuit running. Now the circuit is, what is it called? LPT 1637, and we don't have the TPO 610. We have a slightly different circuit than this. Oh, this is a switchable precision current source. Yeah, we don't need that. But what we're doing is we're doing a high side to low side driver. And so that circuit, what does that circuit look like? Oh, hold on. Oh my God, spicy kimchi ramen was a bad idea. That looks like this. So this is off of one of their white papers on how to do this kind of thing. So they have a 2N3904. I have some of those. I have a bunch of those because they're a Jelly Bean part. So this is a nice easy to find part project. We have a 0.018 ohm resistor, and we did a little bit of calculation and figured out that if both this resistor and this resistor are 2K, then everything works out. With the 0.018 translates into the proper voltage levels that our current sensor wanted on the low side. We had to do a little bit of calculation because this is the least number of parts that you would need in order to make a current sensor. And so that's what they use. And they put it into this microcontroller, into one of the pins, and they sense it there, and then they display it onto a readout. This one is for voltage, and it's adjustable. But the current one is just simply reading across a 0.018 ohm resistor. A precision 0.018 ohm resistor. That's good. It's got just like a little filter here, and this is going to limit the amount of current that gets into the micro. So it's turning it into a voltage level that represents up to 150 amps, but then it's sensing sort of that micro voltage here. And so we want to turn our high side current into that same voltage here. So V out, 0 volt to 2.7. So when we did all the equations here, and God knows I hate doing math on stream, we did all those equations and we figured out that 2K resistors in both locations are ideal. They need to be matched. They need to be very well matched. And ours aren't so super matched, so we're going to be off by a little bit. When I move to surface mount, I'll be able to match them a little better because I'll actually have 2K ohm resistors. And maybe I could put a potentiometer in that too. I could have 2 potentiometers even and try to like really dial it in properly. We'll see where that goes. Okay, so bonk. I finally got the parts in. Let's make a little test board for this guy, for this little guy right here. Look at that thing, 1637. Is that a willow hair or a me hair? I don't know. Yeah, LT1637. Now let me get the pin out up on camera over here because we're gonna put it in the breadboard first. And since I could only find surface mount ones of these, well, actually I could find both, but since the chip is so expensive, I only bought it in surface mount because I wanted a bunch of the surface mount ones in the final circuit. We can use these little breakout boards. Now these are super cheap. You can buy them like pretty much anywhere. You can find them on Amazon. They're basically breakout boards for surface mount components. Now this one specifically is a breakout board for a surface mount component. It doesn't have any other components on the bottom. I have a couple with components on the bottom, and that helps you kind of author an adapter circuit if you need to, or just something weird. I see these used a lot in science, but if you're prototyping a board, like, you know, you can use your surface mount part if that's all you got. Using these boards. Now you can also just make your own. You could use perforated prototyping board and put down a little Kapton tape and then glue your chip down and just have wires going out to your pin headers. So I don't know how useful they are. I have them. they make things slightly easier, but not that much slightly easier. It's a strange relationship with the different processes that we use around here. So I need header pins. Header pins. Square pin headers that are not at a right angle. That's actually kind of a big ask. Kind of a big ask. Oh, here my dog's back. She got her butt washed. There's a store around here where you can take your dog to them, and they have little booths that you can bathe the dog in. So she just went to one of those in preparation for a social function that she has to go to. Got a social function that she's got to look fly for. Okay, here's a couple square pin headers. A wise man would get some. I don't know. They're more durable, like if you're going to be throwing the component into a bin after you do the breadboard stuff with it. If you're going to throw that into a bin, it is more versatile than doing the point-to-point soldering, but it's not that much more. It's not that much more. It's, you know, I don't know. It's hard to find a place for stuff like that. Where are my wire cutter? Wire cutter pliers. What the? Where are my wire cutters? Yeah, that's strange. Maybe that's what the scope's sitting on? No. Yeah, we'll get this all on the scope and then we'll test it out now that we have the appropriate part. Where could they have gone, Ed? This is one of my primary tools. I have like 5 tools that I use, well, more like 7 tools that I use almost constantly in the shop. And that particular pair of wire cutters is one of them. And so if it goes missing, I am out of sorts. Because what if I need to strip a wire? So let me see if I can just find it real quick. It usually wanders only over to one other desk where it is not there. Okay. What else do we have? A squirrel with the guns out. Let's see here. The other place they could have gone is over on this desk. No. Use them anywhere around here. Weird. Okay, so they're probably under a bunch of stuff where they fell into a bin or onto something, and I'll find them eventually. I can use other tools in the meantime. It's just, you know, these tools shouldn't go far from the desk. That's the sort of rule around here. I have an affiliate link. Those are the links below. Chat on Twitch. On Twitch, there are affiliate links, and you can just add that to stuff you buy on Amazon. Oh, here they are. They're actually just hiding in the bin. You can get the URL of the end of the affiliate link from Twitch. Go. So I need 4 pins on each. 4 und 4. A MIDI keyboard I want to connect to a Teensy. It's a dumb MIDI device. I want Teensy to make music from it. There's a lot of really good tools to help you do that. I mean, just like on the Teensy's website, on Paul Stoffrigan's website, he's got a whole thing about it. About how to do that. It's a lot of fun because I made the fire cannons that I made for Camp Bisco X. If you look up Camp Bisco X fire cannons, you'll see a link leading to Peter Parker, who's a VFX guy, and you'll see what we did with those fire cannons. But those are MIDI controlled. And so I made an Arduino Pro device that took MIDI in, and it looked at channel 0, and it looked at the note. And so channel 0 from C up or whatever on only on the ivories, not on the black keys, would trigger a fire. The 10 keys would trigger a fire cannon. And it would look at a non-zero, I think, velocity. I forget which parameter I looked at in order to trigger that specific relay. And that relay flipped 12 volts out to a solenoid. Drawer would be wonderful to have. Probably not easy to find. It's Grizzly. Grizzly Tools makes these, but I don't know if they make these anymore. They may not make them anymore. I bought these around 2010, 2012. So they are getting up there in the years, but I don't know if they make this one anymore. They make the one that's just a big opening, which I was going to also get and have one separate for soldering and one for tools, but I don't think I could find them anymore, and they were a little bit expensive for what they were. And this works out perfectly for me. This one little set of drawers to hold all of my probes and tools, be it common or seldom used. All right, so we're going to solder an IC. We're going to solder a surface mount IC. For those who have never done that before, this is actually quite easy to do. It's one of the things that I like doing because it's so easy to do. There are a couple different methods to do this. We can solder each individual pin, or we can drag solder across the whole thing, or I could just touch the iron to all the pins at once and slide the chip into place. The way that I like to do it, and we'll use one of the larger bits for this. you don't necessarily want the smallest soldering iron bit you can manage. You want kind of the largest one you can manage, because then the solder will cooperate a little bit better. So you put a decently large tip onto your soldering iron, and then you solder one pin. One pin will anchor it in place, and then we will tap just a teensy little bit of solder to each pin after that. I bought smaller solder to help with this process. If you have trouble with it, you can try looking up videos about drag soldering, because drag soldering works quite well. Don't buy an X-Acto knife. X-Acto knives are dangerous. I'll say it. X-Acto knives are dangerous because as you work with the knife, it's going to loosen itself from that shitty handle that they have. If you really want to be working with precision, get you a scalpel. Get you a non-sterile scalpel and some non-sterile scalpel blades, because these things click into place and they stay in place. They stay in place enough for surgery. They stay in place enough for whatever precision knifing you have to do. All right, so corner. So basically, these are little adapter boards. Oh, actually, you know what? I should probably hold the... I'll do this first. I'll do the through-hole stuff first. Let's get this out of here. Yeah, buy a scalpel. Scalpels are so much safer and easier. All right, stretching. So when I'm soldering, the soldering iron, first of all, make sure your soldering iron is turned on. You want to see how quickly this 300-watt soldering iron works? Boop. And then 1, 2, 3, and now we're up to soldering temperature. So yeah, step 1 in learning how to solder is make sure that your soldering iron's on. Step 2, don't touch anything metal in the front of the soldering iron. None of this metal, you can see how hot it is. None of this metal should be touched. All of those stock footage pictures are wrong. They're dangerous and wrong. All these young actors holding this stupid soldering iron by the hot part. You'll learn very quickly where you're supposed to hold the soldering iron, but it really is not a process of trial and error. You'll know where you're supposed to be holding the soldering iron. And I hold it like a pen. I hold it like I'm about to write something. Hold it like a pen. Now, there's sometimes I switch grips on it. It depends on what you're doing. One of the most important things in soldering components is that you anchor your hands. You can put your hands on the table. You're allowed to do that and use your fingers to ambidextrously kind of move around the soldering iron. Listen, your dexterity, if you think you shake, try anchoring yourself. Sometimes just putting a pinky finger on a surface is enough. I am working on a prototyping board, so this is lifted up from the table a little bit. Typically, I will use something like a miniature vise. Not everybody has one of those, and I understand that it's a very expensive tool to use for that kind of thing. If you really want to hold your work, there are things that are designed to clamp on circuit boards. There are types of clamps that will hold on to a varied amount of stuff. If you lift it up from the table just a little bit, then you're taking advantage of the fact that your hand is three-dimensional and you can actually rest it on the table. You don't want it too high, because then you're going to be floating the iron like this, and then your whole arm ends up shaking it, right? That would be a case use for putting your pinky on something and then soldering it from there. So hand positioning is just as important as if you're welding something. You just got to be comfortable, and then your heartbeat is managed and your hands aren't wiggling all over the place. I use a dry sponge because that just works for what I do. You want to keep that tip not looking like it does right now, which is full of crap, because the solder may distribute unevenly on it. So I just give it a couple little pokes into the dry sponge, and it's all raring to go. Now, if solder has trouble sticking to this tip, or if it blobs unevenly, I actually do have a tip cleaner that I can use on this, but it's horrible, awful chemicals invented by Radio Shack in the 1980s, so I don't really want to necessarily use it a lot. But you put your soldering iron at just a little bit of an angle, and if you really want to take advantage of the surface area of the tip, you could go for exactly the angle that the tip is. Typically, that's not sort of possible. That's not necessarily feasible. But what you can do is just butt this up against the two things that you're soldering together, just like that. And the idea is you're supposed to be heating up the metal of the components and not putting the solder directly against the iron. But you can see here, that doesn't really work. There's a lot of area around those things, and it's taking a little bit to heat up. So what I do is I force the issue by putting the solder just a little bit up against the tip, and then that gets flux and solder. Flux is a material that coats what you're soldering. It holds in heat, and it keeps things from oxidizing. It keeps your joints shiny. This solder was supposed to be lead-free. I would suggest you work with lead-free if you feel like you're going to be soldering a lot. But the old school people And I don't mean old school respectfully. I mean the people who you're really supposed to not listen to will say that lead solder is the only way to go because it looks so clean. Well, unleaded solder has come a long way, and not being exposed to lead is nice. I've been soldering for a long time, and I've been exposed to a lot of lead. I don't know if that's why I'm such a fucking weirdo, but whatever. You apply it to the corner, you add a little bit of solder, that rosin core is going to apply a little bit of flux, hold in all that heat, and then from there, what you're supposed to be doing is heating up the joint and adding solder to the joint. You can see there that it flows over, and there's a little bit of a clear substance that has sort of surrounded it. Now, you can clean that after the fact. You can throw it into an ultrasonic cleaner, you can brush it with a toothbrush, you can put a little bit of acetone on it and brush it off. I don't care because this is a test circuit, so we don't need to do that. We're just going to solder it down and not worry about the flux. So anchor the one pin, anchor the other. The reason I have this plugged in to a perforated prototyping board is that these pin headers are made out of plastic, and since they are made to the bottom dollar, they are made to be as cheap as possible, and they use cheap plastic, and cheap plastic does not tolerate soldering temperatures. So if you're sitting here and you're soldering in a pin header onto a board like this, and you apply heat for a particular amount of time, even if this is anchored in place, those pins can start to wander around and become loose. So plugging it into the perforated prototyping board, you can actually see, or sorry, the solderless breadboard, you can actually see that that metal is bleeding out the heat just a little bit. Sometimes you can see the whole track will heat up. So the other purpose of the board is that it's holding everything nice and square, so I don't have to think about it. So anyway, I use partially leaded solder. The unleaded stuff is fine. If you have trouble with it, you just turn up your soldering iron. You want to be able to mitigate the amount of time that you're applying heat to a pin, though. If I had a juiced up unleaded soldering iron, I would want to be careful with these surface mount pads, because the only thing holding this copper to the board is whatever they used in order to glue the stuff down. It's basically copper glued to a circuit board, right? Maybe not necessarily glued, but deposited onto a circuit board. Whatever interface that is can be harmed by heat. If you have a via, that's like a rivet. It's got the board material on, it's got the soldering material on both sides of like either a plated on like tube, or it's an actual insert that's been expanded into place. But when you're soldering to these surface mount pads, if there's not a lot of stuff surrounding them, if they don't have a via on them, they can be fairly weak to heat, especially if you're doing solder rework, which is where most people start learning how to solder. They'll get an old PCB and start learning on that. And so those traces can like rip off if you're not careful. So you want to limit the amount of exposure to heat. It shouldn't be too bad unless you've juiced up your iron for unleaded. I run my iron at 666 degrees Fahrenheit. And that does just fine for all the stuff that I needed to do. Silver solder is more for like holding stuff together mechanically, right? All the pros I know use Ace console repairs. Lewis Rossman, Computer Booter, Northwest repairs use leaded solder. Yeah, but you shouldn't be using leaded solder. I really think if you're going to be exposing yourself to this stuff, if you're going to be doing like odd jobs with soldering, and if you're going to be building stuff, it's better to use the unleaded stuff and not expose yourself to it. I know they like saying that those solders don't work. They tried them early on and nobody thought that they worked right. But I've used a lot of unleaded solder and it's fine. It works just fine. You don't need lead in there. At least partially, which is what I use. Partially leaded is fine. Leaded solders are full of contaminants. Yeah, it gets all in your fingers too when you're soldering. It's good to wash your hands after doing this too. I've been exposed for like my whole life to leaded solders. But I do also have a floor fan sitting like right next to me. Yeah, get your lead from paint chips, kids. Just get it from paint chips. It's a better source. And all the doom and glooming about like micro hairs forming on the solder. It's like, for our applications, we're never going to experience that. My thumb is shaking. Stop shaking, thumb. Stop it. Stop it. Ah! Man, it's really shaking a lot. It's an involuntary shake. All right, so basically you saw what I did there. One anchor pin, and then you slide your component into position. Now, because we are using a microscope, which is essentially just a camera with a lens on it, we're using a microscope in order to see closer. Now, you can buy all kinds of really cool looking headgear that people use for cross-stitching. Cross-stitching hobby tools work quite well with soldering stuff. I have a friend who got sewing needles, these big metal knitting needles that he uses as external like pins for his scope. Pretty cool stuff. But so we've anchored one pin and we slid the component into place. Sometimes your component's going to be sticking up after that. It'll be up at a weird angle because you didn't notice that you're soldering it and putting it in a weird place. So what I did there is after I'd slid the component in and gotten that one pin soldered and all the pins lined up, I went to push it down a little bit. I just went like that, push it down, and then you can, if it actually does press down, you reheat the pin and that reseats the component. And then you're ready to go. So from here, we could either do drag soldering, which is where you apply flux to either end, load the tip of your iron, the big tip of your iron out, the big tip of your iron up with solder, and then just move across. And then surface tension will solder all of your components and they'll look perfect. This is right up to the edge, isn't it? I don't like that pad. I like to have a little pad sticking over the edge to solder to. But we're not going to do that. I'm going to do it on an individual pin basis. So I will just tilt this thing. The power supply wires are getting in the way. Tilt this thing over and just go pin for pin. Actually, we want the other way around. Other way around. We'll just go pin for pin and just add a little bit of solder. Now, because these go all the way up to the edge and I can't see under the pins at all, actually, this is misaligned, isn't it? It is. It's misaligned. I need to fix that. So yeah, while we have it here with only one pin soldered, it's easy to realign things and make it all work properly. No, I can't actually, because most of us here who aren't talking are not that kind of user. So no, I can't. All right, so repositioned, put back in place. You have to understand, the majority of my viewers do not know about this stuff. They say I talk very complicated stuff, but I talk it good. And if I have soldering stuff up on screen longer, there's a lot going into what I do. So no, I won't do what you ask. Sheesh. All right, so in we go. Pin for pin basis, and just add a tiny little bit of solder. What I'm doing is I'm trying to get it under the leg because these pads don't stick out in front at all, which I guess maybe the TS, because this is an SO8 package. The package that the silicon is put in can be surface mounted, can be through hole. This is basically adapting it from one to the other. But in the case of this is TSOP8 instead of SO8. And I guess that means that it's, I don't know, either narrow or something. The pins are not as spaced out. So what I'm trying to do is get solder under the leg, and it's not heating it properly. There it goes. So I want solder to flow over the entire leg. You want it to look wet, like as if it still has water over it, because I mean, essentially that's kind of what the solder is emulating. It's water with surface tension that coats stuff. So once you tin it, once you coat it, it cannot be uncoated. You can remove solder from it, but there's always going to be a little bit left over. So we're looking for, hey, what's up, Blue? How you doing? So we're just looking for kind of a wet appearance and not like a bulgy appearance. We can't really see very much though, because this is kind of under the pin. These really, there should be a little bit sticking out of the front, but as long as I get some solder on there, it's going to kind of look like a boot, and that's fine by me. So just like that. See how that kind of flowed in and everything kind of looks flowed over and wet. Of course, the unleaded solders don't look very wet. They have a matte appearance to them. And that's also what the sort of old school people hate, is that matte appearance doesn't look like a properly soldered joint. Getting under there, get it a little bit of shatter. Come on, buddy. Let's go. Oh, that was a disaster. I got solder everywhere. Although if there's solder on this side of the iron, maybe I can flip it and just take advantage of that. I think that got in there, but I don't think I trust it without kind of doing that. There we go. That should be pretty well soldered. There we go. All right. Okay, so for better or for worse, this thing is soldered. It's not, you know, ideal. I would rather be able to see that the solder is flowed over the whole thing, including the front, but I think that'll do. So this thing is just going to take that pin out and flip it 90 degrees and put it over to our solderless breadboard. Now we have to build the circuit. The thing is, the circuit that we had before, I think on the old school people, yeah, they get real nettled when you talk about lead solder versus lead free, but it's not that big of a deal. They just like to make a lot of noise. More interested in returns than if their solder is shiny. Listen, I've spoken to a lot of engineers. I know a lot. I consulted. I lived in that space, and I've heard all the complaints, and they're not founded anymore. I know. These are truths that you don't want to hear. Okay, 3 to 44 volts input, 0.018 resistor, LT1637, and all this nonsense that we've got sitting out here. We need to make this circuit. So I have extracted from the other board, I have extracted the load sense resistor from the current sensing thing. We made a load, which is just a bunch of 7 ohm resistors in series, and then we have our LM3904 sitting right there. But the problem is, this is a dual op amp. This thing has a single driver in it. So I need to remove basically the whole circuit, and we'll just start over. This is our 3 volt supply, which is what things are going to be running on in the end circuit. So extract the MCP 6000 and whatever that's probably dead. I'm actually going to throw this out just so I don't accidentally use it again. It's like a 60-cent chip or something like that, and we just, in one foul swoop, we turned it into dust. And so we just basically, we could have just put a bunch of change into a machine and called it a day. I could have burnt a dollar bill, and that would have been just fine going forward. Oh well. All right, so the ones I want to keep together are these 1K resistors. I've got 2 sets of 1K resistors. Those are the ones that are going to be doing the scaling or whatever of the current that's coming in. This is going to be the one that goes across the load, and then let's get some of the support stuff out of here, and we'll have to figure out how we're running power to this thing. We're going to power it off of 3 volts because that's what we're going to power the screens with. 3 or 5. I think we'll go with 3 for this particular test. Either one works. And 3 volts ensures that we don't accidentally blow up the analog input of our microcontroller. We did not supermatch these 1K ohm resistors. We're just going to see if this solution works. I should have lead in my solder and asbestos in my lungs. Whatever happened to that? I used to be exposed to that, and I'm fine. Gets cancer. Is completely unhinged from when fuel had lead in it. Okay, I need the pinouts here, so let's refer to the data sheet. See, the little piece of silicon chip that they put inside of these components that we buy can have all kinds of different pinouts. It just depends on what surrounds that little tiny thing, and it's going to be a very small thing at this point, considering manufacturing nowadays. So we need to look up what the pinouts are. This one has a pretty standard one. I think this is a standard for a singular op amp. So NC, or null, but then power V minus and V plus. That's in a weird place. 4 and 7. So just to be nice to myself, I'm going to put the pinouts in here, and this will be the document that I refer back to when I go to fix this thing in like 7 years. 7, 4, output is 6, and then in minus is pin 2, and then in plus is pin 3. There we go. Control S. Okay, cool. So that's our pin out. I don't need to look at this anymore. And now this is what we're going to build, so let's get going with that. Spring arm. People who own actual repair businesses use... Well, that's because they're one guy doing it, not like a factory, I guess. But, you know, and again, these guys usually come from the days of when all the solder had lead in it. And I don't think in my opinion, and remember it's all my opinion, I don't think they've really given a good chance to the modern formulas and given it the high heat that it requires. And they have no reason to, you know. It's like, I know this works, so I'm going to keep using this. But again, like, not exposing yourself to lead is kind of a neat thing. It's kind of nice not to expose yourself to lead at all times. Because, like, I don't know, if you're sitting there saying, you know, lead's fine, lead's totally fine, that's objectively wrong. Like, it's objectively wrong to touch lead and then touch food and eat food and touch your eyes and touch your face after touching a bunch of lead. You know, like, you don't want to do it, and I don't know why there's pushback. I don't know why there's pushback against these things. I mean, yeah, there's some of that. I run into some of that too. I run into some of that too, where the solder joint is crystallized over time, and you have to introduce a little bit more solder to make it kind of an alloy. And it's leaded, it's old. Unleaded also tends to crystallize a little bit more, but there are ways to work around that. It's just, you know, you're used to your process, and so you stick to what you know. A lot of these people, that's what they know. It's just, you know, if I went back, I should tell myself to not use as much leaded solder and or to just wash my hands more. I've had no serious health repercussions from lead, but I do have type 1 diabetes. And I did play on a windowsill when I was a little kid that had paint dust on it, and almost got taken away from my parents for having elevated levels of lead in my blood. They went on vacation, and the tests came back from the children's hospital, because I happened to have a blood test at that time when I was a little baby, and I had elevated levels of lead, and the city of Philadelphia was this close to taking me away. That was a bad weekend for them. They thought they could go away. I got them back, though. By the paint in my blood, I swear. Yeah, pushback against unleaded solder is just one of the most annoying things in the world. They took lead out of our gas, and now I'm mad because I'm a boomer and I don't know that I actually am exhibiting the signs of lead poisoning by getting so mad at fucking useless crap. All right, anyway, those are my thoughts. You can argue with me, but I'm right. Because I'm the streamer, and I can keep talking about this until I'm done. Between pin 2 and 3 are where this thing should reside, and yet I've made it span 3 pins. I'm smart. Okay, so how am I going to do that? Well, let's get this thing hooked up to power first. Power first. We're really arguing about RoHS today. I'm not arguing about RoHS today. It is useful and good, and less lead better, even in electronics. I don't understand. One person can come in and totally derail all of this. This is not up for discussion. It's just facts. Okay. So what am I doing? I'm hooking this thing up to power. Hooking this thing up to power. Pins 7 and 4. So we're going to do 3 volts. So I'm going to put my 3-volt regulator in here. And if we recall, in, out, ground. So in is coming from the rail, which we have hooked up 12 volts for some reason, even though we're working in 3. In, out, ground. So that's in and ground for a voltage regulator right here. And then ground is hooked up to pin 4. Yeah, that's going to be annoying. So pin 4 is over here. I don't want to do that. This is really annoying, actually. Let me just move this all the way up here, and then I can get to it, I guess, just across the front. Across the front. That ain't the pin. That ain't the pin you want. So I need slightly longer than blue. Slightly longer than blue. Yeah, solder pots are only good if you're working with tons of wires. You know, I can be like you guys and bring up an anecdotal example and say that the people I know that do big wiring harnesses, you don't use solder pots. But solder pot is exceedingly dangerous because you've got a like multi-100-degree pot of molten metal sitting in front of you. That's hideously dangerous. So. All right, let's see here. What is all this? I can't keep up with you guys. I can't keep up with you guys. There's a lot of text there that that I'm not going to read. Happy for you, or I'm sorry that had to happen to you. Okay. Pin 1, no C. Pin 4 is power. Pin 7, it's such a weird pinout. So because chips were, back in the day, they were little circular cans, and then even before that, they were tubes, we count the pins 1, 2, 3, 4, 5, 6, 7, 8. Is that the opposite way of clock? Yeah, anti-clockwise. We count them anti-clockwise because in the original like electronics, when you would actually put stuff on a board meant for cutting bread, aka a breadboard, which is what we call this thing, you would screw down a little holder, and it would have contacts going anti-clockwise around the tube, and so you would count them from a gap anti-clockwise. That's why a notch symbolizes where your pin 1 is. In our case, there's not really a notch here. There's half of it is sort of at a 45-degree angle, which I really don't like. I don't like that kind of marking. I would rather there actually be a divot in the pin. Oh, and it turns out we put the thing in upside down. That's just fantastic. That's just fucking that makes me happy. Okay, so all things considered, this is pin 1. So I'm actually going to reverse this. We could put it in the right way, but I'm just not going to bother right now. It's a bunch of work that I don't want to do, and since, yeah, whatever. You guys got me mad. All right, so there's our pin 1 is actually here. That's so annoying. Is that correct? Yes, it is. Okay, so the text is upside down from where pin 1 is. That's really strange. All right, anyway, so that's pin 1. Pin 1, 1, 2, 3, 4, 5, 6, 7. This is our negative, and so I guess I'm going to have to hook the rails up to each other. So we'll have to go over to here, and that is the job of either a green or I think a yellow will do that too. I'll grab a yellow from another part of the board, bring that over here, and so pin 7 connected to ground. I mean, our ground is also right here, so maybe I should just do that. We'll just go with the local ground. Ah! It's kind of shocking nobody was backing me up about lead. Usually there are people that would back me up. Oh, we need to also jump down to here. Right there. Why do I have like stuff on my hand? What is that? Gone? It's just showing up in this light. Strange. I'm nasty. All right, anyway, we got ground locally. It makes things a little bit more cluttered, but I think that'll be fine. We don't have much circuit to go in here. So now we need to actually hook up the parts of the amplifier. Now, over-the-top amplification is something that I've never heard of before, but now apparently it's a thing. It's a specific product that I bought, and it is able to take up to 40 volts into its differential input without blowing anything up downstream. Pretty cool. We're too lead-headed. Yeah, apparently. I don't understand. Okay, anyway. 0.018 ohms. So I have that. It unfortunately does not span across pin 3 and 2 like I want it to, but let's get that set up. Hope you're having a good day. I had an okay day until just recently. I'm fine. Everything's fine. Okay, so we're putting between pin 3 and the input, and then pin 1 of the 2M3904. What's that going to look like? What is that going to look like on here? Let me think about this. So 3.3 volts is only going to be used for powering up the device, and we have that all hooked up. And then if we put this here, this is our 0.018 ohm resistor that goes between pin 2 and 3. So I can pull these over here, and they'll jump the gap. I mean, alternatively, I could rebuild this so that it actually just jumps 1 pin gap, but whatever. But we need this to go, we'll go from pin 2 here. And then pin 3, I guess would another blue one do that? I might not. Might need something a little longer than blue, which is hard to find. I think that's this one. I don't think that's going to work. Let's just see. No, we're done talking about that. I'm not talking about it anymore because for some reason I have to defend against getting lead poisoning, which is a weird thing to do. It's very surreal. Okay, so there is a 200, in our case, 2K ohm resistor that goes between, oh, I see, RS and 33. So actually, this goes away, and now I need a 2 kilo ohm resistor that goes between this line. So actually the one on pin 2 goes directly, and then it goes to the load. So one of the pins of the load goes here, and the other pin of the load goes here. This is what I'm looking at. This is what I'm looking at between 2 and 3, but pin 3 has a 2K ohm resistor on it, and it also feeds over to the 3904. So I need to think about all that stuff at once. So pin 3, this pin here, goes to both the resistor and it goes over to here, and then it also goes to the 3904. Oh my god, this is bending my brain off. All right, so let me get the resistors over here, and it's just a pair of these. So this one from pin 3, and then that pin is pin 4. Pin 4 is our ground, so I got to skip over that. Some of them are no connects, so I could actually potentially use them as just jumping off points. There, and then here. And then this junction is not the one with pin 3. This junction should be, oh, that should be this. Okay, so maybe I need to put these flat on the board. Let's just bump this one out and make it a flat on the board style resistor. Same with its buddy over here. And then that'll enable us to do the jump all the way out to the pin. We're doing it kind of sloppy today. It's not going to be totally clean. I need you guys over here so I can do this cutting without totally blocking my shot. Where are my cutters? Cutters! Again, in those drawers. They're just right directly available. So I like, my setup is something that I've come across after working with stuff for a very, very long time. I've been doing this as a hobby for a long time, and the slow evolution of the setup has been a constant. Well, that just bridges it directly over to the, damn it. It just bridges it directly over to there. Let's just like take this out, and let me just do pin 3 first. I'll do pin 2 later. So if I go like that, then I directly connect, which is not what I want. I wanted to actually have 2 sets of resistors on there. 2 resistors on there, rather. So I'll just do this. There to here. And now this junction is done. This is the one that I need a bunch of other stuff to connect to, like the 3904, and that has to connect at the collector. I hate this particular package of electronics. This thing was very popular in the 80s and 90s. It is still popular today. It is still a very widely regarded and used package for electronics. The reason I hate this is not specifically anything to do with the mechanical layout of it, but what is it? its three-dimensional shape is very easy to mess up. But it's a letter D shape with a flat spot on it. So you just look for the flat spot and you know what pin is what. 3904 pin out, and you get a whole bunch of different image results, right? These are from data sheets that are trying to explain to you which pin is which. But if you'll notice that if you look up something like a 3904 pinout, or if I look up a TL074 pinout, you do get a lot of different art styles. But with a TL074 pinout, you're looking at a drawing. There's very seldomly, if we go to Google image results, there's very seldomly a three-dimensional chip showing you an isometric view with pin numbers on it, because that's not necessary. Because when you're looking at this thing, you know you're looking down at the package and those are the pins. Now, sometimes data sheets will be kind of evil and they'll flip it around. But, you know, the pin 1 marking is very clear on these chips, and you get a top-down package. They can do that in just a simple drawing, black and white, and you can just see what pin is what very easily. And when you're building your circuit, you just refer to this thing, right? But with this particular type of package shape with a 3-pin, what is it, TSSOP or whatever that is? What kind of package is that called again? Anyway, TO92 rather. TO92, see, SOT23 is at least a little bit more clear than that, but with the TO92, all the datasheet manufacturers had to eventually, not all of them, but you know, they generally had to go to a 3-dimensional image, because when you're looking at just that D with a bunch of pins on it, you don't know if you're viewing down from the top or up through the bottom. And a lot of data sheets don't even specify. And a lot of 3904s have suffered as a result. It's annoying how confusing this package is, and you always need to write it in 3D. Everybody can argue with me about that, because apparently that's what we do today. It's very, very annoying. But anyway, I got a pin out now. I know which one's which. The collector is pin 3, which when that D shape is facing that way, it's there. Okay, so spring arm, and then this one goes to, let's do the microscope view. One of them goes to the output, which is over here. The output I'll just run a wire through over to this side. We'll mostly be constructing the circuit over here. So I need one of these pins, and that would be going from the D shape. That's this one here. These two can be a little closer together. This one will be a little further apart. And just give that a little bend there so that it's flat. And so I can go like this. It's a little bit more compact than I would like this circuit to be. I'll have to figure out what the best way to build it is on a little PCB. So the base is in the middle on this one, and the base goes to the output. So I need this to go to, I think it's that pin. Let me double check with my notes. So pin 6. So 876. So it's actually this one here. Has to go boop, boop. So let's get a boop, boop for that. I guess this wire will probably do. Let me see how close that is. 6 there. Give it a bend. Where are my tweezers? Are there? Tweezers help, although sometimes these are pretty bad. Okay, so just get that down there like this. Ugh, okay. Ugh, it's really sloppy. I don't like it at all, but that's what we're getting. That's what's doing it. That's just going to do it. So that output goes to the base here. And then this pin also connects to pin 3 on the inside of the resistor. So this pin here goes to this pin here. That would be the job of a very short jumper indeed. I have. Which I have. Come on. There we go. Careful now. Carefully. Yeah, okay. This isn't pushed in enough that I can. Okay. All right. Get it out of there. Get it there. Okay. Tight working conditions in here. All right. Let's just do a little boop like that. That'll help me plug it in. Nice short jumper right here. Pin 3. So from the collector Oh, that's the base. Wait a minute. No, 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 no. No, 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 no. The collector, which is here, needs to connect to pin 3 and a 2K. Oh, I see. I messed up. I screwed up. Oh my goodness, I screwed up. This needs to be 1 pin in. Bend that down a little bit. And we can just do this. That's pin 3. You basically, like when you do something like this, you go node by node, right? And revise as you go to try to make the best representation of the circuit you possibly can and have it be as presentable as possible, because you're going to be troubleshooting it. And that's the most frustrating part. It's when nothing works and you don't know what you've done and everything is a complete mess. That is really, it's like the lowest point in building circuits. So what I do is I go node by node, and I actually know some people to go through these and highlight what they've done. It's like, I've connected this, I'm going to put highlighter on it. You know, having a printer in an electronics workshop is a good thing, because you hit Control P and then you can just jump in there and you can highlight stuff that you've already done with a highlighter, and you have the circuit on a piece of paper on the desk sitting near you. I have multiple monitors to do this, and I have MS Paint to do this. I'm not going to mark up this drawing, so I'm just going to do it by the seat of my pants. But I go node for node. So you basically break it down. Like this pin 3 is connected to this side of the resistor and is connected to the collector of the transistor, and you build up that node. That's what I've been doing, is just going through bit by bit and putting all this stuff together like that. And it may not end up being in a good spot, or I might be forced to do something that's super sloppy, but you just kind of roll with it until you absolutely can't stand it, and then reauthor different areas. Notice how this resistor is not in the clip. It is, in fact, in between the clips. That could cause problems with it barely contacting. That's why I don't like these tiny leads on these things. But since the margins on electronic sales are so thin, we end up having to see, and then it just mangled my resistor leads just because the pins wouldn't engage. I feel so persecuted. I can do this better with the tweezers. Where are they at? Here. This, when you deal with like a new breadboard, sometimes these little clips are a little bit too rough to get through. That you can't get the pins in, and then it'll bend your leads. Stuff like this, of course, is fine because these are super strong, but these are like super flimsy, very, very low amount of metal leads on these things. These are lower wattage because it's just what you get 1% in for some reason. So inserting them into the board sometimes mangles your lead. In the past, what I've done is I've gone through with a pin tool and just poked into each of these and flexed them once so that they would be able to actually do something. So on the output of this right here is where we put a 2K resistor to ground, and then our V out comes from there. So our voltage output is coming from there. I guess what I can do is I can do the resistor vertically to ground, but we haven't hooked this up. I guess we are going to hook them both up to one another. Yeah, we're going to turn that into a ground, so I actually don't need to do this anymore. I can clean this up a little bit. So pin 7 goes to ground. I'm a little indecisive with this stuff. Let's see, that one is power, this one is ground. And then I also need a 2K resistor to ground made out of two 1Ks. Here's one 1K as an 11K. No, wait, no, that's wrong. The problem with handling resistors with tweezers is that they're barrel shaped and they'll fly out of the tweezers if you pinch them too much. Okay, so we're going, of course it's at the gap. It's always at the gap. Damn it! Stupid thing. Why everybody betray me? Oh my god. Don't fight me, stupid. Okay, there we go. And then I guess this one I'll do horizontally just because it'll fit over the gap better. Or 2Ks or two 1Ks. Don't tell anybody. get that out of the way just for right now. Take this and just... See, that wire's getting in the way now. It's so annoying. There. That's a little better. Pack it in a little better. Okay, so our V out is going to be on this pin, which is, it's kind of packed in there a little bit, but at least we got that. So that goes to ground with the 2K resistor. This is our V out. Our load resistor is here. This end should be connected to 12 volts. So this end will go to 12 volts right here on an appropriately slightly singed pin. Need a smaller gap than that. So where is a yellow jumper? A yumper! In yellow. So plus 12 over to here. Oh, come on. There we go. A yumper. Okay, so yellow jumper to there. That connects our 3 to 44 volts to that resistor. The 0.18 is here. The other end of the 0.18 goes to pin 2. So this one over to here. That is going to be a big jump. We can do that just going across the front here. We'll just go right across here. All the way to pin 2. That is not what I wanted. Okay, much longer. We're getting there. We're going to be able to test this thing soon. And hopefully we see a voltage swing of little volts. I thought I scared everybody off. Kind of did. Oh, this is a little shorter than that. Red. Red has got it. No, red's too long. One of these. Ah, it's not. Come on. So these kits, the cheap ones, they get kind of awkward at sort of the interstitial lengths. There's like the short ones, there's the middle-sized ones, and then the super long ones. But there's this distance that you just can't seem to bridge a gap in with these. So I'm just going to leave this like that. It's kind of awkward, but I don't really have anything else that fits there. Maybe a red one? Let me just check. Oh no, red's way too long. Red's way too long. It's somewhere in between the two different sizes that are in this particular bin. What about this one? Oh, that'll do. This bin is starting to become a little bit too crazy and mixed with all of the different wire lengths, so I might just chuck it and buy another. I bought a pack of 3 of the kits for like $14. So it's like after a year of use, it's kind of paid for itself. All right, so from positive 12 through our sense resistor, and then here is where we connect the load, because it also connects to pin 2. So the load resistor over here goes between that and ground, because it's a high side. So we put power pin here, and then ground pin here. And now that's connected to our giant 7 ohm high temperature resistors. These are moderately high temperature. The really high temperature ones are those big ceramic ones. The ones you used to have in your RC car and it would get hot enough to burn you. So they did speed control. They just threw it through a resistor. Is the worst way to do. Okay, so 2K to ground on the output right here. That's where we put our scope probe because we're looking at voltage. So scope probe is over here between ground and this pin right here. This is also, this is a dual purpose thing that I'm doing right now. I am connecting all of the remaining connections to the circuit and I'm checking it over at the same time. So the base there goes to the output, which is pin 7, because of the way I put this in. 1, 2, 3, 4, 5, 6. Sorry, pin 6. Pin 7 is power. Oh, pin 7 is... Whoa, 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 whoa. Oh, wait a minute. Pin 7 is 3 volts. Pin 4 is ground. 1, 2, 3, 4. I have it hooked up wrong. And that's why we check over. That's why we check over our circuits, people. Wrong. So pin 4 goes to ground. Oops, that goes here. Pin 4 goes to ground. This one has to go to ground. That's awkward. I can move, I guess I can move us up a little bit. We can move this here. Hey, what's up, Cactus? How you doing? Uh-oh, one of these is fighting me. There we go. And then this can move up. Everybody goes up a little bit. Everybody up just one. You go up to here. That didn't actually plug into the... Ah, damn it! Fucking thing sucks! Okay, hold on. Why is silicon such a bad glue? Is this like a joke, or are you? Is it just like a statement? It sounds like the setup for like a bad joke. I hate these tweezers with this stuff. There you go. Move this thing up above that line. Oh, and now it's impossible to plug in. I'm so disappointed in myself right now. Like 3 days ago, still not hardened. Silicon rubber glue, do they make that? Or are you just talking about like caulk? Caulk isn't great. I've used it for some stuff before to kind of hold it together. It's not really meant for that, I guess. I don't know. Cafuter silicon. Silicon isn't sticky enough. Interesting. Yeah, I don't know. I've never really worked with it that much. Okay, so all that stuff has been moved. Pin 4 here goes to ground here. So I need a green jumper. Green jumper. To pin 4. Where's pin 4? There it is. All right, so like that. Now that's grounded, and now pin 7, which is not the one that this wire is hooked up to, right? Yeah. Pin 7 goes to power, which is this pin here. So I need to go like that, which will be done with one of these. Oh, and then this goes away. Jeez. Would have shorted everybody out. Don't want to do that. Get it there by any means at this point. Oh, that's actually not going to reach, so this doesn't need to be moved in. Okay, like that. Come on, buddy. This is a struggle. Go to the store and buy some glue. You just grab anything in a storm. Oh my god, this whole thing is fighting me. Okay, like that. There we go. There's power hooked up. That's really sloppy. I don't like that at all. That's really nasty right there. I don't like it, but I'm gonna live with it because I'm trying to get this test done. So anyway, power. So it's in from 12, out in the middle, going to our thing, ground over here. Power's hooked up. Ground goes to ground, correct? So pin 1, nothing. Pin 2 goes directly to the load resistor and down to the load. The load resistor then connects, load also connects to ground. Then the load resistor connects to a junction of a 2K, I should cross that out, 2 kilo ohm resistor, which is this and this. So the junction of a 2 kilo ohm resistor and 3 to 44 volts, which is our 12 volt connection right here. That resistor then connects to pin 3, 1, 2, 3 right here. Pin 3 also connects to the collector of the NPN transistor, the 2N3904. And the collector is to the right when you look at the front of the D. So if you've got the D in your face and you're looking to the right, the collector is there. So Right here to the right, collector. Base is in the middle. That goes to the output of the amplifier, which is pin 6, or the damplifier, I don't know. Pin 6, and then the emitter goes to a 2 kilo ohm resistor to ground, correct? And that is our voltage output. So the scope, and that'll eventually be the microcontroller, but that'll go in like this for now. So over here we have 12 volt input, but what we don't have, and I've got 12 volts going to there. Oh, I do have the grounds connected. Ground is connected to ground, and this is 12 volts. Are we using 12 volts down here? We're using positive 12. We need that ground, though. We have the ground, and we have positive 12 volts. Yeah, okay, cool. So this is positive input voltage and ground. So are we using... We're using ground, but we're not using positive input voltage. Ground is ground. This is ground. This is positive input voltage here. Input voltage. Okay, good. All right, everything's checked over. We're good. We're good. Let's get this thing powered up. Now, power supply is still at 15 volts because that's going to be our power input to the whole system, to the whole module testing module. So red wire positive, black wire ground. We're ready to test this thing out and see if it does anything. Exploding is a thing that it could do, but I mean, we did check this over, so I'm pretty confident that this thing should operate right off the bat. And then depending on the values of our 2K resistors, we're going to see if we get predictable results. Now we have this thing monitoring voltage on channel 1. So if I turn this thing on, 3, 2, 1 power, we should get nothing. Great. Okay. All right. All right. All right. I see that. I'm picking up what you're putting down. Where did I mess up? Well, it could be in all the values for everything. Looks like I've got an LED on the 3 volts. If I unhook my load and I hook my load, hook, unhook, doesn't matter. We are seeing something happening in there. All right, so let's turn it off. It's also drawing 300 milliamps, but that's through this. We should get the equivalent of 300 milliamps through the thing. You just came in here and your first comment is calling me a nerd. I don't think you understand my relationship with that word over the many, many years. I love lead solder, so much nicer for work with. The whole RoHS compliance is crap. The amount of lead in electronics is so little compared to anything else that contains lead. Oh well, lead-free it is, I guess. Are you pantomiming a dog shit opinion? Because that's what that is. I don't know what to tell you, man. It's just a terrible opinion. But I gotta fight it every day. You guys can tell, people watching can tell that for some reason, yeah, there it is. See, for some reason, I for some reason have the completely controversial opinion that constant exposure to lead is bad in electronics. It's bad. It's bad. It's demonstrably bad. I don't understand why everybody has a counter opinion to that. It's so strange. Strange. There's like a macho thing involved in it too. I know it's cleaner, but people don't give the lead-free solders the proper chance. All right, anyway, the formulations have changed. They're not what they used to be. When unleaded solder originally came out, all the old school guys tried it and they went, this fucking sucks. I deserve to have lead. And they take a little bite out of a piece of lead and chew on it as they work. Yeah, exactly. Lead solder is only good for eating. This is the circuit. Our results should be at 300 milliamps. We're probably not going to see a ton of current through the 0.018. This is just done to kind of match the amount of current that goes through the current thing. But let's just try and see if our results are similar. Maybe I need to juice up the scope a little bit and go closer to the amount of volts, because we should be seeing an amount of volts coming out unless our transistor's broken. And that could be the case. It might be that the transistor's broken. I just don't understand why I always have to fight against the opinion that lead is bad. It's like, what are we doing here? And a lot of the time these guys poo-poo it because they're like, it's fine. It's fine. It's fine. And there's not that much of it. But like, You guys doctors? You guys know about that? I mean, buy whatever's cheap, but also no, like, don't expose yourself to lead. Don't expose yourself to lead. This isn't a controversy. Like, I'm going crazy. I'm going crazy. How am I arguing against multiple people that lead is bad? I don't understand it. Look, it's not really up for discussion. You guys can go up against medical science if you really want, if that's the hill you're going to die on. Yeah, it's like really, really bad. It's really bad for you. Okay, holy shit. All right, anyway, let's zoom in on the scope a little bit and try to ignore my inane fucking chat that wants to die on a very deadly hill. All right. Zoom in on the scope. What are we at right now? We've got 2 volts. Yeah, so that's, I mean, we're really going to be looking at millivolts here. I mean, we can also try to calculate what 300 milliamps is going to look like on the scope. With 2K resistors in there, I load is equal to V out. So basically 300 is, or no, 0.3, because it's a third of an amp. 300 is equal to question mark over 2,000 times, and then R2 over R1 is just going to be 1 because they're both 2,000. So it's going to be V over 2,000. That's a big number. Wait, oh no, RS. Oh, sorry, it's not 2,000 here. Those just cancel out. Hold on a minute, my math is wrong. V over 0.018. So we multiply both sides by 0.018 to cancel it out. 0.018 times 0.3 is equal to our voltage. That's tiny. That's a very tiny voltage. That's not really going to look like anything. I mean, that's what the equation said it would be, though. So, calculator, 0.018 times 0.03, 0.00054. I'm starting to think that our equations are bad, and maybe we should feel bad. How did we get the answer? For 3.3 volts, we're going 0.018. Well, wait a minute. That's, oh, at 3.3 volts across the 0.018 ohm resistor, we're getting 183 amps. So that's at the theoretical maximum value. This is just what we bring to the table. We have, if we have 183 amps on the line, 0.018 produces 3.3 volts. So then I guess I took that and I scaled it in. What did I do with it? Was it 2.7 volts? Okay, so I took 2.7 volts over 0.018 is the maximum of 150 amps through the 0.018. And then we figured R2 is equal to R1 would be 2.7 over 0.018. And if we then have 300 milliamps with the 0.018, then we're going to have we have very low voltage, 0.00054 volts, question mark. That seems a little bit weird, but V equals IR. Oh, you know what? I could have just started there. I could have just started there because that's this equation. Because that's all we boil it down to is V equals IR. But they do an I is equal to V over R. So 0.018 times 0.3, which is 300 milliamps. Did I do 0.03? Did I do too many Yeah, I did 0.03. Okay, I calculated it wrong. So we'll get rid of a 0. That's still very small. Hello? Oh, there we go. There. Oh no, wait, it's multiplied, so maybe I'll do a little better if I 0.018 times 0.3. No, it's 2 zeros. Yeah, I got it right. 0.0054 volts. That seems like a very, very tiny little voltage for us to be sensing on. Well, does this thing, I think, measures 2 decimal places for amps. How does it do that? That's crazy. How it do? All right, so then in that sense, the scope up on screen, we're going to be looking at super tiny voltages. Hold on. There, 50. It's like 0.005. It's 5 milliamps is what we're going to see. So right now we're looking at 50 milliamps. Oh wait, that's the wrong value here. Okay. There's 10 milliamps. There's too much noise. You're saying it should be 5.4 millivolts? What did I do wrong? It's 0.018 times 0.3 is 0.054. Yeah, 5.4 millivolt. Okay, yeah, you're right. Yeah. You got that. I got it right. In the end, it took a little work. Doing math on stream is extremely difficult. So if I turn the output on, it did go negative. Why'd it go negative? This is me flipping output on and off. Went to negative 25 millivolts. Is it inverting? I guess it must be inverting. Because, yeah, this is an inverting amplifier. But it says 0 to 2.7. Did I hook it up wrong? Let's see. The scope ground goes to the minus pin. The scope positive goes to the this pin. The this pin is connected to minus over here. And that is supposed to be ground on the schematic. Why am I getting a negative voltage out of this? That shouldn't be possible. This is connected on pin 1, 2, 3, 4, 5, 6, 7 is connected to the out. Sorry, 7 is connected to power, the 3 volts coming out of here. This thing is powered off of positive 12 volts in out ground. I mean, I guess double check that my pinout is what I think it is. It's never easy. It's never easy. It's always a struggle. Always a struggle. You say something simple and suddenly you're in a fight and you're fighting for your life. I'm fighting for my life out here. Let's see. Where do we get like a better pinout? I don't think we really do. They're probably not going to display. I really dislike when they have that angled side on the thing. That really is annoying. It makes it very difficult to follow what's going on. See, over the top current sense is what we're building. So that's that right there. Then this is, no, this is the one we have. They're not showing us the angle on this. Maybe that's a different package. Yeah, here it is. So there's the angle, and pin 1 is on the angled side. Okay, so that's pretty clear. So here's the angle. You can see right there that that side's angled. So that is pin 1. Pin 2 and 3. Pin 2 we've got correct. 3 we've got, yeah, I mean, other than damage to the 3904, but it seems to be pretty definitive that when I turn this thing on, here, I'll go back to this one. For some reason, it goes into the negatives. So if the load is connected from ground to the sense pin, which is, again, how it should be done. And if I disconnect the load, oh, so I'm bumping the ground wire. Ground wire is a little shaky. Move that to a more stable one. There, okay. If I so much as slightly disturb the input, it goes all crazy. Too far away. And that goes from ground to ground, and this is definitely power. And then this whole thing's powered up. Nobody's getting hot. Nobody's getting hot. So there's our... And then right here. Why is it negative? Is it because it's inverting? But it says, it doesn't say anything about V out being negative. I don't understand that. It doesn't say anything about it being negative. And we're following the circuit to the T, right? Yeah. Over the top current sent 0 to 2.7 volts. Our RS is 0.018. Load to ground. Load from the... Maybe I got the inverting and the non-inverting inputs mixed up. Let's double check that. The plus and minus pins. That may be what's going on. Pin 2 is minus. I got that right. Did I actually cock it up here? Pin 2 is minus, and minus goes out to where the load is connected. I got it right. Pin 2 minus out to load. Pin 3 plus goes to 3904 and the resistor. And the resistor also goes here to the load. Yes, that's correct. 2K. And then base goes over to the output of pin 6. Pin 5, pin 6. And then the 3904 has a 2K ohm resistor to ground. This is definitely ground. It's connected to minus. What the heck? I mean, yeah, you could just put a capacitor in there and, you know, defeat the... Well, I know, because it's DC, but... what in the world? Positive resistor. I'm going insane is what's happening. Pin 1, pin 2, pin 3. Should I be inverting these in order to get positive output? Yet my output is negative. I'm sitting here with this resistor cooking below me and wondering why this is happening. I mean, scope is definitely connected to ground. It's positive going over here. Do I have any shenanigans enabled on this channel? Show me your shenanigans. Nothing. Fine off, channel 1, trigger, blah, 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 invert off. Invert controls are off. Everybody sees it. Strange, strange, strange. What's going on here? Everybody's all weird. Here, let's re-center ourselves. Oh, whoa, something shorted out. Output off! What was just shorting out? Well, you can't see right now, but my voltage level dropped to 0.4 volts. Did something bump up against something else? Oh, I think it was these bumping up against each other. That sometimes happens when your leads are the same size and they're exposed alligator leads. So let's turn this on again. Yeah, now that's holding 15 volts, but it's still inverted. That's so weird. I didn't mix up the inversion. Pin 2 goes to the load, just like they say. Minus pin, pin 2. Double check the datasheet for the 15th time. Minus pin, pin 2. I don't think the plus pin turns into pin 1, does it? No, in minus is always pin 2. Plus is pin 3. Pin 3 in plus. Pin 3 in plus. 7 is V plus. V plus, pin 7. Hello to the dishes and to the dishes, the dishwater. What is that phrase again? I've heard that. I have heard that. I just don't know what the usage is. Because, like, we would be referencing something off of positive power. Oh, TAMO, that's right. That's right, I've heard that before. Man. Good old TAMO. That's hooked up to positive, that's correct. And then the 1K, 2K rather, over there. Ah, that thing's getting kind of warm. I'm going to unplug the load. Boop. Raw to the dishes and the dishes to dishwasher. What the I don't understand. I mean, it's no, this should be a non-inverting setup though. Because they say 0 to 2.7 volts, and yet somehow we're getting negative on our output from this circuit. And the equation, the transfer function is clear. We've canceled out R2 and R1, so it's V out over RS, so it would be I times R is equal to V. I know, it's weird PSU like magic going on. How does this thing even produce negative? It shouldn't be able to. That would mean that I'm referencing it off of positive. So here's our reference on the minus line, which is connected to this minus line. I'll turn this off while we poke at it a little bit. This could not be more simple. Output goes down to here, which then goes to this regulator, which then goes up into our positive pin. Pin 4 goes to the negative, which goes to the negative of the voltage regulator. Make sure that we plug that in properly. In, out, ground. Yeah, that's correct. So negative over here. So this is our minus that goes to the load cell, because the load cell is also connected to ground. And then this is the minus of the probe with the alligator clip like that. So that's all connected to that minus. And then this wire connects our two minuses together. And this minus goes to the voltage regulator. And then the voltage in goes to this pin here that goes to this rail. Nothing else really needs positive 15 volts. So that goes out to positive. And here's the ground going to the power supply. So this is 15 volts in, positive and negative. Negative referenced with the 2K resistor here. 2K over here, and referenced on here. Why is it negative? What the hell? How is it negative is probably the better question for this. How is it producing a negative? It doesn't make any sense. I'm referencing something backwards is what's going on. Or maybe my plus and my minus is actually flipped. The counterfeit part. It's a 1637. That's the same chip. And this is the LT1637. Let's get the specifics. 325. What? Oh, S8, MS8. Where's that marking? E3? I don't think we get the order part number on the outside of this thing. 3 and 5 volt electrical characteristics? No. IMS8, 737, CN8. I have none of these markings. Well, we know that it's in this package, so I don't understand. Pin 2 is in minus. And pin 2 on our diagram minus pin 2 over here, direct connect to the load. That's this wire here. Through the 0.018. I've looked at this circuit about 12 times and I cannot understand why it would not be working. Positive 12 volts here goes to the resistor to pin 3. Yep. And the load resistor. Positive 12. Yeah, there's no other. Okay, so as far as I'm concerned, as far as I know, there's no other way to be hooking this thing up, and I got all the pin out exactly right. Why so negative? Listen here, you little shit. I don't know why this is happening. What have I done? Why is my scope reading a negative voltage? Let's just double check with the multimeter. You know, if I look at the channel, it says it's not inverting. Off. That's on. This is off. We'll go with this then. Trusty old scope. This thing's still warm. So we're going on scope, and we're going between ground and this pin right here of the 3904. We should be letting positive voltage through. I do not understand why we would get negative on there. Let's just see. Turn this on. Negative 0.15. Oh, you guys can't see. Negative 0.15, which is in line with our calculations, sort of. It's supposed to be 0.2 something, but, you know, it's a very small amount of voltage. Why is it negative? Oh, my God. Am I supposed to read that between 3 volts and ground? Like, okay, we take it to reference from positive. 3 volts right here. Whoa. Will be from 3 volts there to this pin. I don't see why you would not want it to be ground reference, though. Whoa. That's not right. That's getting a huge swing. This should be 3.3. What? Potential problem. There's our 12. And then this should be 3. Yeah, so we're getting all of our proper voltages there. Oh, 11 volts on that one. That would be bad. Collector and emitter. Do I have that mixed up? I don't think so. Let's check. Turn this off. 2N3904, which I have no reason to believe is not working unless I just blew it up. 3904, generally collector base emitter like that. So in this case, it's the other way around, but collector goes to pin 3. Base goes to the output pin 5, 6, pin 6. And emitter goes to a 2K ohm resistor to ground. Collector, base, emitter. Emitter on that side. Yeah, that is correct. I mean, you know, this is the point where I'm sitting here looking at the square going, how peculiar, we only manufacture circles here. And the other guy goes, well, I guess we just do a negative now. But like, I mean, that's not the expected result. I don't know where that voltage, negative voltage is potentially coming from, unless the potentials are just flipped and we should be observing ground versus this pin. And then that gives us a positive 0.02 volts with no negative sign on it. But it's backwards. It doesn't make any sense. Shouldn't we be doing something differently? Maybe we can find that white paper that explains it. Let's see. Lamp outage detector. Neat. Over the top current sense. LT 1637. Oops. Rugged op amp. Blah, blah, blah. Where is a white sheet? Other demo circuit. Plus minus 10 volt. Fully operated. Blah, 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 blah. Download the insecure file. Ugh, do I have to go to the folder for this now? Come on. Very annoying. All right, downloads. Oh, .asc. Oh, that's like a simulator thing. Let's delete that. Don't need it. Can't open it. Bonk. Yeah, it's an LT Spice thing. RMB size 50 nanoamps. Datasheet PDF. Do they have a white, like a white paper about it? I would love to know, because it seems like I need more information here, because nothing about this equation says inverting, and nothing about the setup says inverting either. It's set up as a non-inverting amp. Why would then I get the wrong thing? And I don't think I've mixed anything up. It's not like I have a polar resistor or anything. Those don't exist. Actually, maybe they do. Every time I say something definitively, chat has to go in there and throw their little wrench in my spiel. 3 volt to ground, and we are measuring it across those potentials. I mean, there's no reason to think why this isn't measured to ground. Why is 1637 TA04? That's weird. The only thing I can think is that our pluses and our minuses are flipped, but I don't think I did that. Okay, triple, quadruple check. Plus pin goes to all that stuff. And the plus pin in this data sheet. Scroll, scroll, scroll. Plus pin in the data sheet is pin 3. So the one that goes to the resistor is pin 3. That is pin 3. 2, 3, 4, in which case, if I got the numbers wrong, no, I didn't get the numbers wrong. That is definitely pin 1. We just soldered in the chip upside down, just because the angled side of the package is in fact the pin 1 marking. That's what that shade is on the right side of this, or on the left side rather of this. It's just the shade symbolizes the cut in the IC. So pin 2 is definitely there. Oh, this is so annoying. Why is it like this? 7 is V plus. Shutdown pin we're leaving floating, which I guess is fine. Pin 2 is in minus. Pin 3 is in plus. In plus is the one that gets looped. Plus is the one that gets looped. Pin 3 is minus, that goes direct. Wait a minute, I think I did get them mixed up. Wait a second. Hold on a second. Wait. Pin minus goes to that stuff. Pin plus is on the top. And minus is pin 2. Plus is on top. Pin 3 is the one that goes to the resistors. Pin 2 goes directly to the load. No, this is correct. Damn it. The one time I had a glimmer of hope. And for some reason, it's negative, and that doesn't make any sense to me. Is the microcontroller going to be able to see that? I don't know if it is. There's no way I'm putting like an op amp in there. It doesn't make any sense that it would go towards negative, though. It would get more negative because we're only in a DC situation. There should not be that sort of thing. What the fuck is going on? What's going on? Let me ohm out some stuff and just see if all our connections are being made properly. Maybe it's a result of something not getting a proper connection. So we go to ohms. I check my grounds. Ohms. So I go to ground over here. And I check this one. Actually, I can just do this. There we go. Let's see. Positive load to ground. We're going to get whatever equivalent of resistance that is. 28 ohms. 7 and 7 is 14. 14, 14 is 28. Relatively accurate. You guys can't see it because of the glare. 28 ohms to the load. Let's check from ground to this pin. 1K. Wait a minute. Ground to this pin. 2K. Close enough. So then from this pin to the input, again 2K, that's fine. Oh boy, this doesn't make any sense to me. I don't know if you guys have any idea of how frustrating this is. Output pin 300K. Oh yeah, because it's going through here, so to the base. Half an ohm, that's good. That's the output pin. Positive power, works out just fine. Plus here to plus here should have no connection. Good. This is the 12 volt in, so plus here to 12 volts. Plus here to 12 volts. And it's connected just fine. Ha ha ha, what fun. What fun, what fun. We have fun. Ha 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 ha. Ha ha ha. Such fun. I do not get it. I mean, if I flip plus and minus, is it going to actually like invert it and then I'll get positive power? Or do I blow the thing up? Although it is over the top. But I have my load connected the way that they have it here, and it's a high side current monitor. So my 12 volts here goes into this. And I'm sure it's just fine. It is. 12 volt goes through there, and then here it connects to the load over here. And we get predictable results, but they are in negatives on the scope. This is baffling to me, and maybe I shouldn't be so baffled. What if I just flip pins 3 and 2? Let's flip pins 3 and 2 and see what happens there. Because, like, I mean, if this is inverting in one direction, if you flip these, really what should be happening is 3 volts is being let in through here with the base current. And that's really what you're kind of measuring. You're measuring it across 2K, and you're measuring it to ground. It's the same ground as the load. And that's all we've done. We've done everything to ground. Baffling. Chat, do you have any ideas about this? Because this is very confusing to me. I mean, all we're doing is biasing a 2N3904, right? That's all we're doing. That's what our op-amp circuit is doing. So if I flip minus and plus, I don't know if that's going to have the right effect, because the 3904 doesn't really want to be operating with a negative. If I have negative current across this, that doesn't make any sense. Because I have the 0.018, and I've got current flowing through this way. My load is connected properly. That's so strange. E-ink price tags? No, I've not heard of those. That's a good application for e-ink, though. That's a really good one. Look at this. We get negative. Good day to you, sir. This is saying it's positive, though. Wait a minute. Oh, but it's reading bonkers gobbledygook. It needs some filters in it in order to get rid of that, because we're talking about tiny little amounts of millivolts. If we put this into our voltmeter and current meter, maybe it would give us a good reading. It's baffling to me, though, that we flip over to negative. Let me turn this off before I overheat on the desk. This load resistor is a little bit prone to overheating. Got 200 of them and no way to interact with them. Apparently there's a wireless router that supports software to manage it. Can you drop in after the modem and see what the signals are? And then maybe from there, you could take a look at what protocol it might be? There's got to be some information about it out there, right? You've got like a part number and PCBs and stuff too. Oh, it's a very closed source world. I'll bet you that the wireless protocol is proprietary, but the language from whatever... See if there's a wireless module. That would be your best bet, is if you actually have a module that's communicating to a chip. Maybe you could drop in and see what it's talking. Without the full communications loop, though, that might be a little bit more of a challenge. But it might open up some avenues to search in. That's what I would do. I was going to get one of these. Maybe hook it up. Hey, Silvio Russo, thank you for subbing. Yes, sit in the grocery store with one of your devices. Celia, thank you so much for subbing. Let me take a look at what is this horrible abomination? Jesus Christ. What the fuck is that thing? All right. Oh, it's the kitty in the sandal. Okay, the make and emote large thing is very intrusive. All right, let me think about this here. I load is equal to V out over RS times R2 over R1. R2 and R1 cancel out. RS is 0.018. So V out over 0.018. That still can't go negative with positive numbers on everybody. What the hell? I don't understand. We're getting a negative voltage out of the system. So I guess I can try to plug it into this thing, but I don't think it's going to really like getting a negative voltage. A millivolt negative voltage is fine, but R2 over D2. What is D2? Celia Russell gifting a sub to Lev TV Live. Celia, thank you so much for that gift sub. I really appreciate gift subs. Love you guys. Love you, love you. Thank you. This is very, very... sorry, I'm frustrated. I can't understand things. The frustration here is that we've got this circuit that's turning a low side current sensor into a high side current sensor. So like this is what we had before with the 0.018 ohm resistor going to ground, and then we had this pin going out to the low side of our circuit. Instead, we want to monitor the high side. We want to monitor from the voltage source instead of from ground. The load side goes in here instead of going in here. So we're going in here, we're going from here to here, and the way that we can do that is with the LT1673. That will allow our voltage meter to read the 12 volts, to read the 5 volts, without exposing the microcontroller to the 3 and the 5 volts. So it wants to measure across here and get a voltage for the current, because V equals IR. Instead, it's going to now be measuring across here, and it will be getting just a voltage input. Well, it's just going to be getting a voltage input, and then I guess that bleeds it out or whatever. But so the 2N3904 gets activated on a positive power supply here. So why then is this? Because it would just scale to whatever's coming out of here. This somehow translates to negative V. No sound. That's on you. That's on you. My sound works perfectly fine. Let's do that just in case. Okay, so what the heck? Would it be that... No, because we're measuring to here. We're measuring to DC ground. DC ground, and then somehow we're getting negative V, which should be impossible. What are my other probes doing? Is it something to do with the scope? No, it wasn't to do with the scope because the multimeter gets the same numbers. Unless my ground shifted for some reason. I don't know why it would. It's these two that are plugged in. This scope here, probe. This is connected to channel 1. Channel 2 is not connected to anything, although it does have a probe connected to it. But that shouldn't shift my ground reference. Plus, the number is just about the right number. Oh, I see. I see. Well, I did say thank you. Chat, what's going on here? Why is everything crazy? We did modify this one a little bit, although we won't need to mess with it at all. We just need one extra pin to get to that voltage reference. But I'm concerned with it showing up as negative. Because, like, I mean, if it reads the volts, it reads the volts. That's perfectly fine, I guess. It's got a couple of capacitors to ground. I don't know what those will necessarily do. But why is it measuring negative V? What's the scope reference? You guys are not very helpful in troubleshooting this stuff today. Sometimes you guys are helpful. Sometimes you guys argue for having lead in everything you own. I need lead in my socks. Let's see. Is this reference to ground at all? Offset 0 volts. Scale is 10 millivolts. Fine is off. Display is on. We've got none of the shenanigans on there on the acquisition part. Units DC. Bias is 0. Bandwidth limit's off. Channel skew is off. Labels not on right now. Invert is off. That would be an important one to measure. What is our probe and ground? We are currently DC. And we should be ground reference. It's so weird. Here, I can show you. If I turn the output on, give it the 15 volts, all of a sudden it goes negative voltage, which is just baffling. It's just baffling. We're not dealing with AC, we're dealing with DC, and yet somehow our potential has gone below ground. Huh? Oh, my neck just cracked. Oh. What the f... Okay, I guess I'll just try putting it in. I have no idea how to help you, but I'm entertained. Literally drinks lead. Yeah. Man, it's like crazy day today. I mean, this works. We got it working, right? It does seem to sense our 300 millivolts and produce an output voltage. So perhaps if I just put it into the current monitor, it'll just ignore it. I'm just afraid I'm going to break it. I don't want to break my current monitor. Not to mention the fact that it might just not read properly if it gets negative current. But like, I'm taking crazy pills. 2K to ground reference, V minus, and these grounds, well, let's check the potentials of the grounds then. We should get like point something ohms across here. Mega ohm. Yeah, 0.5 is the OL of my scope, so that's the OL of my scope, the overload. I mean, could it be that the extra distance... You tried asking what was wrong? Oh, man. What an annoying thing, huh? racking my brain. I'm racking my brain trying to find solutions here. Trying to think of what the heck is going on. By all means, I mean, we're measuring across that resistor. If I measure ground compared to it, but that just means that it swings that way to negative. We are technically switching from pin 3 pin 3, and that is pin 3. It's pretty definitive. We can even look and see pin 1 coming out and across. Out and across. Pin 1 right there. 1, 2, 3. Pin 3, collector. And our base is connected to pin 6 right here. Pin 6, yep, there it is. Goes over, connects to the base, and the emitter over here, which would be on the left side if we were looking straight at it. The emitter going to a not 1, but 2K ohm resistor. So through there and through there, going to ground. So we're comparing it to ground. If I compare it to the ground on the other side, it should be the same ground, because that ground connects through this, and then down to here, and then back over to where our ground is connected. Where did that just slipped out. I am very, very confused about this circuit right now. There's no surprises. I'm not like connecting something else there. No. By all means, this should work. Why is it negative? It shouldn't be able to go negative. That's the thing. That's what I'm kind of stewing about here. Because our op amp is only being supplied. Well, wait a minute. So that part of we're pulling from here. This is connected to the minus input, which is connected to the plus input through a 2 kilo ohm resistor. So trickling current in here this way. And yet somehow when we read from here to here, that's negative. So that would mean that this ground is being held higher than what we're letting through here by the exact number of millivolts that we get with the equation. Is their circuit wrong? Is their circuit bad? But no, that doesn't make any sense. That doesn't make any fucking sense. What's going on? Oh my God. We're comparing our positive and negative this way. Should this one be the minus? That doesn't make sense though. And this is at 3 volts from the regulator. This is a shared ground for everybody. So it's means by comparison, it's looking at a very, very minor voltage here. Is the scope connected when you measured with a multimeter? Maybe the scope ground and power supply ground have a small difference. Yeah, the scope, the thing was still connected. Let's just double check that. So this ground to this ground. Oh, on DC volts. I mean 0.002. Oops. Although 0.02 is just what we always read. So it looks like the grounds seem to be in sort of the same place. Now if I isolate one, it might wander in a weird direction. So I take this and I measure between here. This isn't super accurate in microvolts, but and we get a little bit of a difference there. We get a little bit of a 0.2, 0.15. Oh yeah, I ended up doing exactly what you suggested. Oops. Come back. Eh. Oh man, I'm just confused. Oh yeah, and it depends on whether or not my leg is hitting the table. because I get big ground feedback when I do that. Don't worry about the scope right now. I'm looking at this. Uh, hmm. I mean, it might work if I just connect the, what do you call it, this thing to it. That number of millivolts shouldn't take this thing out. Plus, there's a 10K resistor on it. Perhaps maybe some of these capacitors will filter us into the positive space. I don't know if that's really going to happen though. Completely baffling why we would get negative voltage here. The thing responds perfectly fine. We get our calculated voltage 0.005. It's more like 0.002, but 0.005 is definitely visible in the scope readout. I can show you. Let's hook it up again to make sure that my ground is connected properly. Let's put it all the way over here. There's scope ground. That doesn't stabilize anything. Make sure this is a nice clean ground. Would you stop going crazy nuts? What's going on here, crazy nuts? Hey, stabilize yourself. Why is it so crazy go nuts? There we go. Okay, so as noise-free as I can make it, especially given that the lights are on. Although if I turn off the desk lights, hold on. That doesn't help much. I put a big RF filter on the lights, so those are less noisy to my my setup. You can see it expand just a little bit with the lights on. Oops. What's up, Tom B? I did. I just verified it with the multimeter. If I measure across it with the multimeter, of course, the extra wires are adding quite a bit of noise. But if I turn it on, well, now I'm not getting anything. Oh, I didn't hook the load up properly? No, that's hooked up. Hold on. I just double check that I'm on the right pin. I'm indeed on the right pin. This is connected. Everybody's wiggled. We are generating heat. Generate steam heat. Lynn Street pulp. Dun, 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 dun. I, oh, let's go. Oh. So depending on where I hook up ground, I'm getting a different, so ground over here versus ground over here, which is negative 30 millivolts. So we are getting ground potential differences. So we move all of our grounds over here. And then if I turn this, well, it's still measuring 5. Yeah, that's nearly, although it is a sort of like comparing noise, but it seems to be measuring to 0.5, which is kind of what we expected it to do. And since our R1 and R2 are off by a little bit, but it's going negative. It's still going negative. Check continuity from bottom left to bottom right rail. Yeah, it appears to have been something like that. When searching for over-the-top current sense circuits, I see a couple circuits where plus and minus of the op amp are reversed. That may be, yeah, maybe we should give that a try, because maybe that's what we should be doing. All right, let's reverse plus and minus. No, we don't have any capacitors. We checked over the circuit about 10 times too, so we definitely have the right circuit. All right, so let's reverse plus and minus, and that'll probably fix the problem. It's just weird. It's just weird that this would happen this way. So I need to go to there, I need that to there, I need this to there. Unless I reverse those two pins? No. All right, so the best thing for me to do is just to stretch, poke and stretch. That one stays the same, that one stays the same. I just pretty much reverse what's going in here. So I get a slightly shorter wire than the yellow. I don't know if I have shorter than yellow, so maybe I'll just bend the wires and it'll be a little sloppy. It'll just be a little sloppy. Be a little bit naughty. There. And then this one goes to there. It seems like the most likely thing is just that the circuit is inverted as to how it should be, and maybe there's a mistake in the printing. Come on. All right. Spread this out a little bit. Go all the way over there. There. So now we've reversed it, plus and minus, on the pins there, and we can see whether or not that works properly. Make sure all this is plugged in well, and then we go over to here, and we look at the scope. And since we are well in the noise area, a couple capacitors might clean that up, but we should see it go up to 0.5. It exploded. What the fuck? Oh, it goes to full positive because of the bias. Wait a minute. How then should this actually be done? Pin 2 going to plus. I reverse pin 2 and 3. Hold on. That's a full reversal. Let's see. So should the capacitor, or sorry, should this thing still be on the other pin for the collector? Should the collector still be on this pin? That would go directly to the load to ground. That wouldn't make any sense. That would change up the circuit too much. No, we're just reversing plus and minus. But apparently that flips it to the point where it's going off of positive input power over here. Should my R2 be going to positive instead of to ground then? True, it did go positive. Let's see, hold on, let's see what the other, there were some other application circuits that were current followers like this, that were in the data sheet. We'll go down here, look at some of these application circuits. Bypass of the small capacitor, protect against reverse battery voltages. Output is affected by input. Overdrive is shown by the initial performance curves. When monitoring input voltages within 100 millivolts of V+, gain should be taken to keep the output from clipping. The output of the LT blah 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 pulled to 25 volt and beyond with V+ and V- 1 nanoamp leakage. The normally reversed bias substrate diode. Okay, there might be details in there. I'm just not looking closely at them. Let's just take a look at what's going on down here. So we have positive supply rail current sense, 200 ohms, 0.2, 200, going into plus, which goes up to there, and then over to a 3904. and 0 to 4.3 volt output through the 200 ohm resistor. Over the top current sense, this is our circuit. Ours shows going into positive. Over the top comparator with hysteresis. Yeah, positive, negative. Just doesn't look like it. I don't know. I don't think the problem is my breadboard. It was, well, yes, no, you're right, it is. To a degree. But then we don't get the right current like no current sensing is going on. I don't know. When I localize all the grounds, everything seems to agree. Maybe if I move this ground over to here as well, so we're all getting ground from right here. I think that may be what I need to do. Okay, so let's take this 2K, and also, wait, I need to reverse the circuit again. So let's put it back to where it was. Everybody back to where you were. I have that jumper. Nope. So that gets squished in a little bit more. Can I adjust to get more voltage? Yeah, I was going to build it specifically for the current meter, and then hook it up to the current meter. But I mean, just for testing, we can probably, you know, flip the values a little bit so that things are a little bit more poignant. I have to find some 220 ohms. That's exactly what I'm doing, Veet. That's the conclusion that I just came to. I can communicate that a little better, so you guys could understand, so you'd know. All right, let's move this in, this in. This one's a little easier to move in. Just kind of get the little squid leg go down a bit more. I don't think I damaged my 3904, did I? I don't think so. Ah, God, it's so awkward. Man, through-hole is just the worst. Just the worst. You know, you can't do this kind of testing with surface mount. You get a little bit more finality to the circuits. You can do a little bit, but a little bit of swapping around like this would be SOL if, let's see, I gotta lift this up a little bit so the pin comes down flat. Go. Oops, now it's twisted the other way. Get in there. Oh no, see, now this one's not plugging. You son of a bitch. Is this really gonna take the whole stream, this circuit? I guess so. Ugh. And I gotta plug it in at this end. What a bunch of ass. Fuck this thing. God, I hate it. Okay, hold on. This circuit sucks. Who built this? Yeah, the millivolt nature of this makes it so that, like, if I breathe wrong, the circuit gets all whack. It's like, I know the part works. I'm trying to make it specifically for this circuit, and because they made this thing measure up to like 150 amps, our calculation values are all over the place. I wish I could get into the microcontroller that they use for these displays. I don't want to make my own, but I guess I could with this circuit. I could make my own, but I don't want to do that. I don't want to do all that work. This ended up being as much work as making like an AT-Tiny 85 do it with a little display, but whatever. Whatever. Trying to piggyback this simple circuit. Okay, so I'm gonna move the 2K resistor, which is two 1Ks in our case, and I'm going to put it to ground here, so that all of our grounds are in one little cluster, and that makes things a little bit more stable. So I need to go from here to here, and none of the pins surrounding this thing I can go to. Great. Oh, that's just great. That's an NC. I could go over there. I can't really get close. I guess I could just solder these together and make them into a yumper. I don't have 2 kilo ohm resistors. I could replace these with 1Ks, but we just kind of went with what the circuit has under display. They're not that kind. They're actually continuous. Do you not think I know these things already? Give me some credit. All right, so we're just going to hastily solder these two together. It's more of an antenna than anything else. Hastily soldered so that I can go from rail to rail. I guess I'll bend them downwards like this. It'll just stick up out of the thing. I don't think you understand, Chester. Earlier today, I had to argue with my chat that lead is actually not fine. They're like, no, it's totally fine and it's good for you. You should use lead in your solder and everything. Because, you know, solder smoke is just flux smoke and you don't get exposed to that much lead. It's fine. Lead is fine. I don't get it's baffling to me that they would argue that point and think that I'm somehow unable to like understand. I don't. You guys are crazy, stupid, and crazy. All right, so this thing then connects there to that juncture, and then that will make sure that all of our grounds are at exactly the same potential. If we're looking at millivolts, it helps to do something like this because then we are sure that everything is reading against itself. It's like, it's crazy. No, lead solder is totally fine. Asbestos is great. Everybody loves it. It's still going negative. You can see it just kind of like boop, boop. Why are we not seeing a positive voltage? All right, so how do we get it to swing to 3 volts? Well, that requires slightly different. Over the top current sense 33 volt to 44 volts. 200 ohms is what they're putting there. We put a 2K there just to match this 2K, but if 0 to 2.7 volts, what if we did put a 200 ohm resistor there? Maybe it's just that R1 needs to be scaled back quite a bit. There's a limit in America? How much lead is allowed in food? Some foods there's no limit. Well, there's a limit to how much rat is allowed in your food as well. That's actually a thing. Still has lead in some of the water pipes. Is really bad for you. Surely they would fix it ASAP. We still have some wooden water pipes in places. Yeah, I think R1 maybe needs to be a lot smaller. So let's get a 200 ohm resistor and just put it in there and just see what it does. So 200 ohm resistor. I mean, I could put a potentiometer on there and we can adjust it, but it seems like maybe R2 needs to be scaled a little bit differently in order to get this to work properly. And if we move it, I mean, we could just scale both resistors back or whatever needs to happen. Here's 1K. So let's get 220 ohms and just see what we get. Let me put a potentiometer in there. I'm going to put a pot in there. That'll make it a little bit easier. Actually, do I have room for one? No, I can't do that. I don't think I can. Yeah, I don't have room for one. I don't really think we have that many lead pipes left, guys. $270, $220, here we go. These are 1%ers, they'll be fine. And then the one that we're doing, this is the 2K going to ground, so this is the one that we have to replace. So this one that goes from here, which is our load resistor, to pin 3. We should get more of a response. And again, this is why we test circuits like this, so that I don't build a permanent installation and then we find out that, you know, for some reason I can't do what I wanted to do the way that I wanted to do it. We may need two 220 ohm resistors. Maybe that's the solution. This is just a little measuring device. You don't need one of these. It's a little bit helpful. This thing is like way too expensive for what it is. It's a piece of plastic, but Pace patented it. You can go on Thingiverse, and if you got a 3D printer, you can get all kinds of stuff like this. Or you can look around on like eBay and like Radio Shacks and stuff like that. I know Radio Shack doesn't exist anymore, but sometimes you find Radio Shack stuff for sale. Places like Amazon, you can go and see if Jeff Bezos has one similar to that, not the same thing. He's technically my boss. I mean, I guess he's everybody's boss because he can buy and sell us like commodities. There we go. Okay, so now I have a much smaller resistor in there, and then presumably over 300 milliamps, we should probably see something in a larger scale where we don't have as much noise. And we do. There we go. Millivolts meet milliamps. So with 2K, it's not moving. With 220 ohms, it's I guess depleting that, and it's not working properly. So if 2K is smaller, and if it's still R2 over R1, we make the pull down resistor 220 ohms, but that doesn't make any sense. And in both the 2K, and as the 2N3904 is activated, that current is being let in to the pull down. So if it's 2K and 2K, then maybe it's, I mean, by means of the equation, it should be dividing it, but the pull down could be larger and the pull up smaller, but then that just lowers the current that goes through it, which would change the number line, I guess. But it's still, our RS is fixed. We can't change that. Think about that a little bit. Because this is 300 millivolts that we're measuring right now. But that's not going to translate into, or milliamps, sorry, milliamps into just about 300 millivolts. But that's not what this current meter is looking for. This is looking for a much smaller voltage. Maybe I do need to dial it in with a potentiometer. Maybe that's the case. All right, so let me turn this off, and we'll get a pot that I can tune it in with. We can tune it to the very small amount of current, or see what the screen tells us when we get that number of millivolts in. That's actually the better idea. Okay, we'll do that. And I'll also get a potentiometer over here. Where are my pots? What have you done with them? What did you do with my pots? Gotta make sure to put the S on the end of that. That's very important. Otherwise, everybody's gonna misconstrue. Potentiometers. I think they're back on the cabinet, I guess. Womp. So we look in here, and I find the kit of precision potentiometers that I bought. It's nice to have the instrumentation style ones with the blue ones with 25 turns, because then you can really dial stuff in. We were getting like a negative voltage. We're not getting that anymore now that we've upped the ante a little bit on it. Ante up. So there was I think there's a couple things going on. I think one of the things was in the distance that the ground was traveling to get to where it needed to go, there was like a mixed potential between the two rails. That's what was able to get us to go down into the negatives. The two 2 kilo ohm resistors fighting each other with the LM3904 in the middle was causing it to barely do anything, right? It wasn't really actually doing anything. It wasn't able to pull that line or to saturate that line because we weren't allowing much current through. We were letting so little current through. Hey, Brink, how's it going? We were letting so little current through that it really wasn't measuring much of a bias or doing anything at all. And I don't think it could fight the potentials there. So now that we have lowered that resistor, we are getting the effect that we expect. We are getting 300 millivolts, 300 milliamps through the load resistor is causing it to go up to 300 millivolts. That's good. That means we're in the right space for the 2N3904 to function. The question is, how do we now get it to work with the equation that we got and the potentials that we're expected to see on the other end? We're trying to mimic the voltage that the amp meter sees in order to get it to read our amps. So the amp meter needs very, very small voltages because it can operate up to some extreme currents. They're like, oh, you could put multiple amps through this thing, which we're not going to do, but it can apparently measure those. And so since we can't get into the microcontroller that powers this thing, we have to cater to its voltage range. So we need to hook up that sense line, this right here, to our circuit and see what it says and see if we can get it to match. So what I'm doing is I'm going to pull this out and we are going to replace this with a potentiometer. Now, how am I going to do this? I have a 3-pin pot, so if I put it right here, then I can jump from here to there. So that's the way it's going to work. That's how it's going to be around here, huh? So let's get this out of there. You're fired. Okay, and then we go to... Damn it! Where did you go? No, you were the right size and everything. I don't know where it went. There was a yellow wire. It was perfect in every way. And now it's gone. I heard it kind of skitter against the desk. I guess I'll just get one from over here. So from here to next to this, just right here, is where, because we're doing this resistor here, and that's a little short. This would be just 1 pin longer than what yellow can handle. That means it's a green, I believe. Green over here. So we racked our brains around this thing for a little while, and I think we've come to somewhat of a conclusion. Without reading a white paper, I don't know the precise mechanisms that would cause that whole thing to fail, but we're getting to the bottom of it right now. And so we're churning on and figuring out what is right and what is wrong with this circuit. So in order to figure out what value of resistor I want there, we need something that basically goes up to 1K, or rather 2K, sorry. So, I mean, if I just put in a 2 kilo ohm resistor there, I could put in a 20. I don't think we're going to have to go over 2K, though. So let me just put a 2K in there. That's this one. And then we'll adjust this until it gets to 300 millivolts. And then we can plug it into the other circuit and see where that puts us. So right there, because that center pin, this center pin is doing nothing. It's just there for decorative purposes. And so now our potentiometer is between these two. And so if I turn this circuit on, we get nothing until I measure it. Actually, it is doing something. There should be a little bit of a response in there. Of course, I got to work until I got to be careful this doesn't like burn anything. Oh yeah, it should go on a heatsink. There we go. Annie up. Man, I gotta listen to that song. By all means, it should not be going negative. That was just the problem with the potentials that we had. Definitely isn't going positive either. Let's go the other direction. I didn't really figure out how the equations are put together, so I don't know if this is going to suddenly swing at the very end or if it's going to slowly. I didn't even check over to see whether I plugged this in the right way. All right, come on, man. We're definitely measuring the right thing, yeah. Oh, God, so much noise. No, settle. Settle out. There you go. Why am I not adjusting anything? Take it all the way down. Go the other way. Other direction. Come on, buddy. Ugh. Okay, let's double check the connection. Oh, output's not on. Damn it. Oh my God. It's at maximum voltage. Where have I gone wrong? That should be moving. I borked something. Something borked. All right, turn it back off. Double check. Oh, it's not even, wait, it wasn't even drawing 300 millivolts. Milliamps, rather. All right, let's double check. Something went wrong. Hey, who subscribed? Aurelio! Do you still have the subboard? No, but the new one is right behind me. So I want to get some headway down on some of these projects. And you can see by means of what I'm doing right now, it's so hard to get just a little tiny bit done around here. It's so difficult. You know, we're getting into conceptual and weird stuff in order to get things to function the way that I want them to function. I am currently on probably the most fractal yak that I've ever shaved. I have a module, synthesizer module that I need to test, and I don't have a good means to test it. So we're building a modular synthesizer testing module, which is something that I've wanted to do anyway, and it'll help me move forward with building and maintaining my friends' modules as well as my own, and tuning my own modules. So right now, what we're working on is the power supply for this cage that'll have my module tester module in it. I need to know how much current my modules are drawing because I need to know whether or not they have runaway current situations, which are usually when you burn something out. So when you burn something out, yeah, Yactyl shaving. It really is. I'm not even done. We haven't gotten to the end of the yak yet. So when I bought these displays that display these nice clear voltage and current numbers on them, we thought, yeah, Bob's your uncle. This is great. Super good. Everything is going directly to plan. The problem is these are low side only monitors. They only monitor the low side. So your current, all of your voltage and current goes through your load and then it goes to ground. But before it gets to ground, it gets routed through this thing. And that's a pretty nifty way to do it. You don't deal with very high voltages when you do it this way. That means fewer computants. That means fewer components, and it means less cost. And so naturally, the only ones that I can get are low side. So we need to convert a low side monitor into a high side monitor. So that's great. You use a current mirror and an op amp. The problem is we have more voltage supply than what supplies the actual microcontroller. We can hurt the microcontroller if we're not careful. So we use over-the-top current sensors, which is a particularly expensive product, unfortunately, that'll allow me to measure currents through voltages that are much higher than the supply to the microcontroller. There are other ways to do this, sure. I'm doing it this way just because we found the white paper for one and we tried it and it didn't work with the other parts. So I ordered the right part, and now this is where we are. So look, I'm in the middle of something, so I'm not doing a workshop tour, but you can see it in the background. My uncle isn't named Bob. How dare you get that wrong about my proud family lineage? God damn it. Okay, so what went wrong? What were nothing. This is hooked up correctly. The wiper of the potentiometer goes to the what? Okay, that fell out. That fell out. Why did you fall out? Why did you fall out like that? Don't you ever fall out on me again. Okay, so that goes in there. This goes in here. Let's just make sure that these two legs of it, the two left legs, are set to 220 ohms, and then we'll get a similar response to what we got before. And this will just kind of clarify things a little bit. So what we do is we put it in a different part of the thing, and then we go to ohms on the meter. Why do people say, and Bob's your uncle? It's like a declarative that the Brits use. Bob's your uncle is the same thing as ta-da, or therefore, or and there you go, and there you have it. They just like kind of mixing it up, those Brits, those plucky Brits. And there may be, I don't think it's like a Cockney rhyming thing. There might be more to it. Okay, so we were at 1K. Because Bob's my uncle. I mean, why else would you say something like that if if your uncle's actually Bob? Milton returns to streaming tomorrow. I might have to raid his channel. The bears shit. And so bears shit in the woods. There you have it. Oh, I see. It's actually very hard to get down to. So there's 220. Man, I was close to 220. So we can see what the effect of raising the resistance on this thing is. So let me put that in here. Gotta make sure I get the direction correct. Just like that. All right, Annie up. That song's stuck in my head and I don't know it. I hate when that happens. Okay, so power supply turns on. And there's a small voltage, which would be somewhere around 300 millivolts. So now what happens as we increase the resistance? It goes down, 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 until we probably reach a limit of what we can supply. Okay, let's zoom in a little bit more. So we want it below 10. Will it let us? Dun, 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 dun. If it shits like a duck, if it tells you it's a duck, if it flips over a turtle in the desert, it's a duck. Why did you flip that turtle over? What the hell's your problem? Dun, 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 dun. Zoom in. I'm in. Dun, 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 dun. There's about 5 millivolts. So we know it works. Now we've tuned it properly. If I remove the load, Mr. Frodo, share the load. There it is. So there it is working in positive volts and not negative. Two things going on. One, our resistors weren't very well matched. Adding a potentiometer, a nice, easy to adjust potentiometer, helped solve that. Two, our grounds were at much different potentials because they're distributed over a very long distance. So I moved all the grounds over to one side, went to measure it again, and it just helps sometimes to see something change instead of everything being static. Since our load is static, it's good to have some variables in there. So now we turn this off and we apply it to our little toy here. So I have 6 pins, of which I only need 5. No, sorry, 5 pins of only which I need 4. And I've got 2 little connector adapters that I built over here somewhere. It's going to be pretty sensitive about this, but it might work out. Hopefully we see the appropriate number of millivolts. Where do those things go? There they are. So I'm going to do this one here. And I'm going to do this one here. And let's see. So if I run power to this, I can run 12 volts directly into this. Might as well just do that. So actually, if I plug this one over here, I can do 12-12 ground, and then the 3-volt regulator is just the internal regulator on this is just going to take that microcontroller to the right voltage. So there's this. That's going to be, actually, that's 15 volts. Wait a minute. I want to be over here. I got Michael Jackson and, what is it? Is it Paul McCartney song? That was in one of those other mixes. One of the yacht rock mixes. Too long. That needs to go to ground. I'm hooking it up a little weird. Like that. So then we're measuring 12 volts. And then in addition to that, I am taking this pin, and I'll just use a big jumper on this. Where are my big wire jumpers, like this one here? Yeah, every component in the circuit is completely necessary. It's one of those. It doesn't, in fact, I have deleted the decoupling capacitors. I haven't included those. There's so much connected to this junction that I can barely, let's get that there. And then that goes to the red wire because we removed the load sensor on this thing. And we instead have basically a direct connection from the red wire into the microcontroller. We've severed ground on this one. That's not something that's going to need to be done on the others. Now, theoretically, we should be able to see 12V, and we should get 0.3A. Let's see if that functions. 0.47. Close enough. I could adjust that. So 0.37, so we're just about there. Bada bingus. Look at that. Let's see how it reads 0. Reads just fine. Hey, look at that. Now we are actually cooking. Ah, how does it feel to be a success, Chad? We don't often get that. And then 12.5, of course, I can adjust to become 12. I might need to get the better multimeter out here. Although this doesn't need to be super duper accurate. It's just I want to be able to measure them somewhat well. But god damn, that was a... Why is everything such a struggle? I mean, look at all the noise that this thing has to deal with. That is some heady noise. And the micro, the tiny little capacitors on the microcontroller probably deal with that. But now we actually have it scaled. I mean, maybe I should just include the 2K potentiometer with this so that I can adjust both volt and amp. There's an onboard pot that's like one of these really horrible, super sensitive ones that when you touch it with a screwdriver and the reading goes all over the place. But okay, now I know what I need to do. What time is, oh, Jesus Christ, it's already 4:30. How's everybody's afternoon? So I'm probably going to end up building the circuits myself, and I'll try to build them on the little tiny PCBs that I have, because they'll just go in the back of this thing. Maybe I should do a standoff. Standoffs where the two plugs are, and maybe I can put my own circuit on a PCB that lives in that area, and then I can have my own 4-pin plug that'll take it down to the rest of the board and do all of the current and voltage sensing. Or no, if I did that, then I still need the two big wires. I still need the two big wires that go all the way down there, because I'll have to cut the input, and then that'll be on the load, and this will be, well, I could just do it with the same number of wires and just run it. Like, these are thin enough for the amount of current that we're going to be drawing through these things. This thing can only supply so many amps. I think this thing can supply 5 amps, so I don't know about that. I might burn up my wires if I have a broken module. I may need to put like a current shunt on the whole thing and shut it down when it gets too crazy. Time to make it the PCB and F360. Oh, Jesus Christ. This is supposed to be much shorter than that. It's supposed to be a quick thing. Maybe I do want the big wires, because then if something draws too much current, this thing is like a beast. What are the ratings on these things? Gotta go to Pololu. I may have to sub it out for a different regulator, to be honest. Voltage regulators. It's one of their main... Pololu makes some awesome voltage regulators. They're very, very good. If you're doing something with robotics and you need a very light but very capable... Oh, there's a shunt regulator. Yeah. I don't want to buy these because they're expensive, but I should probably have something like that in there. And that way I could make it so that it doesn't blow up a module that's already broken. One of those little inline fuses, maybe, yeah. Output voltage is 12. And the ones we have are step down, maybe? Yeah. So it's this type. With the 2 capacitors. Yep, 2 big caps. So at 12 volts... Oh, it's 2.5 amps. That's actually not terrible. I think we could live with that. That size wire should get hot, but it won't blow up. And then it takes 2 to 22 volts. Why? It's only 2.5 amps. I thought it was like 5. Huh. Well, that's okay. 2.5 amps is a lot for a modular synthesizer. If you had a bunch of modules that took up like the max current that you should typically expect from a module, you're not going to get anywhere near 2.5 amps. But I'll also have this power supply powering all of the internals for this thing, as well as making the 3 and 5 volts that this thing requires. So that'll do all right. All right, well, we didn't get totally far, but we did get a positive result out of our current measurement. And I can't exactly scale my shunt regulator. I have one that does much higher current. I think it does like 3 amps, so that one's kind of out of the question. If I had alligator clips, I guess I could jump in on this a little bit sooner. Let's see here. So take that out, and let's do... I need a yumper. Let's go a little bit sooner on this thing and see if we get... So what we... Oh, that's the wrong plug. Nope. I'm looking for... Okay, so it should be a quarter more. 1/4 more current. Going here, right? Yeah. $400 milliamp. Well, that's not accurate. Uh-oh. Uh-oh, it doesn't scale properly. Wait a second. So this says 500 milliamps, and I'm reading 1.3 amp. So the scale is wrong. Does that mean we need to adjust the other... How would you affect the scale? Wait a minute. I'm going to turn this off and let it cool down. How do we do scale? I mean, we're looking at the potential between the two ends of RS. I load is equal to V out over RS times R2, R1. R2 over R1. R2 over R1 and RS are our adjustments. So R2 over R1 is just going to give us one of our terms. But I load is not scaling by anything, is it? Our slope is different, rise over run, and our V is going to be, it's going to need a different factor on it. So that doesn't really matter. Well, they also don't give you full information about R2 and R1's values. If I measure, if I affect R2, what happens to one of you happens surely. I mean, would it be RS? Would RS need to change? Coding since 4 a.m. The righteous nap. R2, RS, R2, R1. We're looking at math again because it's not scaling properly. So we are trying to emulate what the little screen does. And since we don't have access to that microcontroller, I can't edit anything in here via code. All we can do is try to match what current this thing sees. Basically, we try to mirror it exactly, whatever current is across this resistor. We took this resistor and we put it into this circuit down here. And so that is our RS. So RS is 0.018, not 0.2. And so what has happened is that when we're at 300 milliamp, our voltage is 0.3 volt. And we go this way. Actually, we go like this. And the screen goes like this. And we reach 1 point whatever faster. And since I haven't taken a math class in 30 years, I don't know. I gotta figure out how to affect the slope. But like, so it's basically, it's RS, R2, R1 times I load is equal to V out. And RS is fixed. We have a fixed value for that. Unless I replace it with something else. I might have some load resistors, but I don't know what value they are. They might be 1 ohm, I'm not sure. So rise over run would be covered here, even though we've got it multiplied by IL. So rise and then run is V. Yeah, I don't really know what to do here. I think maybe if I replace R2 with a potentiometer, I might be able to affect it a little bit. I don't know in what way. The equation is R2 over R1, so wouldn't I just be affecting that coefficient? But there's more going on here than the transfer function. There's more going on here than the transfer function. We made these close to the same value and they canceled each other out. And like nothing happened. We didn't get any current going down through this thing. It's the scale of the current. Maybe I need to add something here. Just put a pot right there, and then adjust that so that. Or does affecting this get more to go down this way? And so I change this, and then that changes the point of the voltage divider. What's the problem is our slopes aren't the same. As we go up in current, and I eliminated one of the resistors. We have 4 of the same value resistor. So I eliminate one of them and the current goes up by a factor of a quarter, right? So we go from 300 milliamps to something like 400 milliamps, 4 and some change. So we went up to 400 milliamps, but the display said, oh, you're at 1.2 amp. So the effect is a little bit different between the two. So it thought 400 milliamps was 1.2 amp. It changes, I don't know what it changes. I don't think it changes the scale. If I do tune it to this, hold on, let's try. I think the slope of the 2 lines is different. So right now, if I plug in the whole load resistor, RL, where's that? Well, read's totally different. Hold on. 0.2, so it's off by, you know, the heat adjustment is a little bit... Oh, it's not even plugged in. Why are you reading... Wait, why are you reading 0.2? Hold on a second. There, 0.36. So 0.36 with the load resistor at full. So that's fine. That's where it should be. But when I take it by 1/4, and we're running 400 millivolts, it thinks it's at 1.3. So I could adjust that. Oh, geez. Assuming that I have all the fingers in the world. What if you, like, had all the fingers in the world? Six, 5. Okay, so 0.4, right? So then we go back to the full, to the 0.3, the 300 milliamp load, and now I've got 0.17. So, you know, it's moving the number line. It's not changing the slope. Yes, it has a separate current channel. The way it originally did it, I turn this off before I burn my desk down. I'm going to burn my desk down. This is a weird concept, the way we've done this, but what I did is, because all of the ones that you can find, all of the this is the display module right here. All of the current displays that you can find are low side current drivers. The reason they do that is because you don't need more equipment to turn volts to amps. V is equal to IR. You put a resistor to ground, and then you don't have high voltages going into the thing that's sensing how much current is being used, right? You're looking at the potential difference between here and here, but they're at ground potentials. So there's very little difference between these two. And so you can run whatever you want through there, and it'll measure the current, and everybody's happy. And you know, you get to save money and all that stuff. So all the ones I can find are low side current drivers. So what we're doing is we are making a current mirror circuit. And I found these high side they're over the top op amps. They can have much greater voltages on their differential inputs than they have power going into them, and still work with those values. So what we have here is, from the manufacturer, a transfer function that turns a high side current driver into a voltage level. Really good for microcontrollers if you're doing voltage sensing like this is. We're trying to jump in and look exactly like a 0.018 ohm resistor going to ground. Those voltage levels here are known. We know those voltage levels because it's just V is equal to IR. So we can take numbers from those voltage levels, from the potential levels on that, and we can plug it into the transfer function here, and we can figure out what our resistors should be. And we found that 2K was supposed to be appropriate, and it just tanked our whole circuit. So we put a potentiometer in here so that I could adjust it. But it turns out when I adjust it to be the levels that I want it to, the slope of the line is different. And so perhaps maybe I could adjust it here, although the transfer function wouldn't lead you to believe that. We have a load resistor that comes from, or a current sensing resistor that comes from this. It comes from this circuit here. And I wanted to reuse it because I don't want to buy current sensing resistors. They're annoying to buy and expensive. So I wanted to reuse that one and get it tuned to the right values. So it might be a matter of this getting tuned to the right value. Maybe I need something more sensitive than a 3904 to get the right slope. But that's one mechanism behind the display. The other one is that it does do voltage sensing. So it's got this massive voltage divider circuit that's adjustable and allows a smaller, tiny little voltage into their microcontroller, even though they say it can read up to 100 volts. So there's probably some specialty stuff and some special sauce in the microcontroller that makes it able to take 10 volts in on one of its inputs. This one, however, does not go to 10 volts according to all of our adjustments and equations. This is on the millivolt scale, which is tough because then all of our equipment is noisy when we try to read that stuff. So yeah, where we got today is that by putting a potentiometer in here, we were able to affect the scale of this thing. This works. It's just the slope is a little different. And so I need to figure out what I should do about R2. What is U6? Unlabeled. It's an unlabeled microcontroller. So we don't know. It could be anything. It could be anything. But I mean, the circuit, we have what is it, a shunt, no, sorry, it's a Zener diode amplifying circuit that creates the power, and that's 3.3 volts. And so our 3.3 volt microcontroller more than likely would blow up if we put too much current in here. So it's actually good that we have something that's limited to 3.3 volts, so it can't blow up its buddy. Although maybe it can. Maybe it can feed through here and blow it up. Not sure. So I don't know. I don't know what to do here. I guess maybe if I can swap R2 with a potentiometer, maybe I can see if that affects the slope, but I don't think it does. I removed the resistor and I'm using it in this circuit, yeah. What? Basically, this goes 0 to 2.7 volts, and we calculated what the voltage swing is here and made this do the same thing. So with these adjusted to the right values, they will have a similar voltage swing. The only problem is, as more current goes through that resistor, the effect on the voltage down here is too much. So it may be prudent to try putting a potentiometer down here. Maybe that would affect rise over run in some way, but not according to this transfer function. I don't think this is the whole story. Oh no, R2 over R1 could be rise over run over scale. Maybe that is what it is. Maybe it's what it's. But I load is what changes. But it is RS R2 over R1 times IL. So IL's not in the numerator or denominator of either of those. So I can't really, that's not really going to affect the scale over distance. All this is going to do is move it to different parts. No, that would be additive to move it to different parts, but if it's not really rise over run. I don't think the transfer function is telling us everything. Yeah, we did, if, burp, 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 burp. 0.17. Oh yeah, that's because I moved it. But yeah, if I unplug it, burp. 0 reads 0. And this should be 300 millivolts. Well, that scope is just not useful at this range. Wait, why is it not moving? There it goes. So that's about where it should be, 3.7. 3.7 is what it's reading as the whole circuit, over 15 volts though. So it really should be a little less than that. This is 714, this is 28 ohms. 28 ohms at 12 volts. So hold on, it'll be 12 over 28. .42 actually. It should be 0.42. And then what about 3 times 7? So 21. So it'd be, oh, hold on, 12 over 21 over 21. 0.57. So yeah, it's still not reading correctly. So that would be if I took this and I skipped the resistor. So see, it's reading steady 0, steady 0. Put this on here, and then read one less resistor. Damn it! You gotta do this to me. You make a fool out of me in front of all my friends. That reads 1.2. It might just be that I need to use a different load resistor or whatever. Because if that term multiplies differently, doesn't it? I don't know. I gotta take algebra again, chat. I'm not good at algebra. All right, so we'll figure this one out a little later on. We're gonna come back tomorrow, and since it's Friday, I think maybe I want to do like some mechanical stuff. We can like cut some linear rail and put together the POS CNC machine that I'm trying to build a little bit. We're not going to get very far with it, but it'll at least be something we can do with our hands. And then I can do some of the circuit stuff on the side. I still need to figure out how to get it to scale properly. For now, I mean, I could put them together and just say, hey, it's off by a little bit. But I think the ratio of those three resistors is going to be important. I think the R1, R2, and then the sense resistor, if they're in the right ranges, then we should get the results we expect. This is supposed to be something that I just bought off the shelf and plugged in, but I can't sense the high side. I can't sense the low side current on the whatever, so. Well, that's what I was supposed to do. I was supposed to just let others handle this part of it, because we should have been well into building the power supply for the modular synthesizer testing module, but now we're stuck in the power supply synthesizer testing module, sensor, electricity testing power supply module, testing sensor module, power sense testing resistor module. I'm so confused. All right, anyway, here's the end card. This is where my social media stuff is, what little of it there is. I barely post on Twitter anymore, but you might as well check it out. Hopefully the thing handles this. 19 hours, 48 minutes, and 6 seconds, I will be back. We'll be back tomorrow. We're going to work with our hands. We're going to work with our hands. We're not going to work on this shit anymore. We are, but I mean, it's just we're not going to work on it tomorrow. I need to do something new for you guys so that it's not just constantly the same thing over and over again. And in the meantime, don't believe my chat when they say that lead is fine. They are demonstrably and expressly wrong about how much of a non-issue lead is. Lead is a big issue. It is bad. No matter who's telling you that lead is perfectly fine, they are trying to perpetuate an old way of doing things so that everything's fine and all of these horrible chemicals can just exist in the shop. You come into contact with solder, you burn it on an iron, it aerosolizes. You do not want lead in your solder. I promise you the struggles of unleaded solder are not in vain. Now, you can also get partially leaded solder and you can limit your exposure and have all of the good stuff happening at the same time. But lead only belongs in one thing, gasoline. Shut the fuck up. Stop spreading disinformation, misinformation on the internet. Don't be part of the problem, you fucking idiots. I can't even believe what I have to put up